Mike O'Brien had a locksmith license. He said, I wasn't really much of a locksmith, but it was a really crappy safe, so in about 15 minutes I was able to open it for him. And so in exchange for being able to retrieve his passport, wallet, or whatever things, Phil did this picture. And this, of course, is a PDP-11 in the background, and you can see the pipes and dev null down over here and the demons running around on it. And it actually first appeared on a shirt that was printed by a family shop in Chicago. And there were just a small number of these that were made, and Mike O'Brien sort of doled them out to his friends. Okay, well, this particular image was fairly popular, so it ended up being on, well, as I said, the shirt. This case, it was the 10th anniversary of Usenix, and so this was their 10th anniversary shirt. You'll notice in the original that Phil's signature appears down in the lower right-hand corner here, but mysteriously, by the time it appeared it's on the Usenix shirt, his signature has disappeared. And this is an ongoing bone of contention about, artwork. They just like to, for whatever reason, remove the artist's signature from it. Anyway, moving along, the first of the sort of demons that we know today, that you would recognize today, is this one. And this came about when Sam Leffler, who was one of the early developers on the BSD project, had left the project and had gone to work for Lucas movie making, and they had what they called the computer division, because the very first Star Wars was all done with blue screens and models and so on, and there was a desire to be able to at least be able to use computers to do some of the special effects, to add the stars in the background and various and sundry other things like that. Nowhere near what they're doing today, but it was the thing that was the genesis of doing that. So in this particular, so Sam is now at Lucasfilm, and it turns out that one of the things they wanted to do was an animator's workstation. And they had some of the best computer graphics people on the planet at that point in time working there. But these were people that knew computer graphics. They didn't know what someone that was actually trying to do animation would want as a user interface. But luckily for them, a guy named John Lasseter, who was a chief animator at Walt Disney, had come to do a sabbatical there. The hierarchy at that time in Disney, everything was, of course, hand-drawn. So you had the lead animators, and they would draw things 1 second apart, cells that were 1 second apart. And then the next people down on the hierarchy were called the in-betweeners, and they would fill in the 23 frames between those two. And then finally, you had the so-called colorizers, and they were the ones that would fill in the colors of everything there. And they were given just a little bit of creativity, so they could, for example, draw the tail on Mickey Mouse, so they could make the tail do this or whatever. So the lead animators were kind of like university professors. They were the most important people, and so they needed to, every 5 or 6 years, get a 6-month sabbatical to just go off and recharge their batteries. So John Lasseter decided that he would go spend his sabbatical at Lucasfilm. And of course, he was an animator, so now they had somebody there that could actually help them design the user interface for this thing that an animator would want to use. Well, at this point, we were just getting ready to put out 4.2, and we wanted some picture to put on the front of the manual. And so Sam talked to John Lasseter and said, could you just draw us, a demon? And he probably showed him that picture that you saw earlier. So this is the picture that John came up with. And, it looks sort of Disney-esque, the big eyes and all that. And, well, I wouldn't want to say that it was Disney-esque, because Disney would probably have our ass, but just kind of think that through. All right, and you'll notice here that there's a glowing orb, and he's, and the point of the glowing orb there was so that Unix could be put in there because this was a Unix system. All right, so this is what appeared on the front of the manuals. Of course, in those days, you needed a license from AT&T in order to get these things. And so Usenix had a license, and so what happened was that Usenix actually printed the manuals. They'd do the license verification of anyone that wanted to order them, and then they'd ship them out. And there were about 2,000 copies of these manuals. It was a 7-manual set that got shipped. Okay. Meanwhile, notice, of course, no John Lasseter signature is on this picture. Okay, so all is well and good. But of course, it was black and white. So somebody had to, of course, colorize it. And so this is the first colorized version of the black and white. And it was, again, printed on a T-shirt. And so this is what I think of as sort of the first John Lasseter T-shirt. And this turned out to be very popular. And so what ended up happening is a lot of people wanted to use it. So this was St. Olaf College in Minnesota in their computer science department. They wanted to have this. And I quickly, cottoned on to the fact that, if it just got run out and without any controls on it, then I would lose the ability to keep track of who was allowed to use it. And so I required people to come and get a license. And the fee for your license was you had to send me 2 T-shirts or whatever it was, posters, whatever it was you were making. And this began the history of me collecting T-shirts. My husband likes to accuse me of being the Imelda Marcos of T-shirts. I have on the order of 600 of them or so. In fact, under pressure to get rid of some of them, I gave an early version of this talk at the Vendor Summit last year in Mountain View, or wherever it was down in the South Bay. But the point was I could drive there, so I took 2 huge suitcases full of shirts to show off. There's a YouTube video you can see of that particular talk. And then at the end, I just laid them all out on the table and said, all right, if anybody wants a shirt, come on down and get one. And I was nearly overwhelmed with this wave of people, stampeding down to the front. And within minutes, the tables were bare. Okay. So I now have slightly fewer. Well, except, I keep getting more, like this one. I think it's a pretty cool shirt. And I just got it at this conference. Other uses of it, Bay Lisa. Lisa is the large installed system administration group. And, here you probably don't remember the days of wired Ethernet, but this is an Ethernet cable that's being spliced in this picture. Love, Peace, and Ardist. Ardist was an earlier version of rsync, really, not nearly as functional. And, the daemon gets adorned in various and sundry ways. Okay, so that was all the original John Lasseter daemon. So now we're getting ready to write our first textbook, the first design and implementation of the BSD operating system. And so once again, we wanted to go back and get like a real color version of the BSD daemon. John Lasseter is still at Lucasfilm. What had happened was they'd actually gotten the workstation, or the animator's workstation going. John was super excited about this. He returned back to Disney and said, look, it's time for us to move into the computer age. This sort of things we're doing all by hand, a lot of this stuff should be done by computers because it'll do it, faster, better, and cheaper, and blah, blah, blah. Disney was having none of it. They were like, no, our signature is we do hand-drawn stuff. And look at all our competitors that are all doing these really crappy versions. They can't do it nearly as well as we can. And if they start using computers, it'll get even crappier and we'll be in a better position. And so John was despondent about this because he really was excited and wanted to bring this technology into animation. And so he left Disney and went back to the computer group at Lucas. And of course, enough time had passed at this point that Lucas had sort of done his first 3 Star Wars. So he had just boatloads of money pouring in while he was from the first 3 Star Wars. Then there was like a long pause. And suddenly he had all these expenses, and he needed to start cutting some expenses. And so he said, all right, this computer division, this is like super expensive. I've gotten out of them what I need anyway. And so that was spun off as Pixar, which was an independent standalone company. And of course, John went with that group. But sort of in that time frame, Sam basically talked to John and said, look, can you do a colorized version of the demon for our textbook? And so if you look, you can see that there's sort of a stippling background on this. It's because it was just a piece of cardboard that had been used for shipping something that John pulled out of the trash can. He just had a pen in his pocket that he drew the lines, and then some chalk that he just filled in the colors. And the whole thing, according to Sam, was done in like 10 minutes. And it's signed. If you look underneath the tail there, you'll see John Lasseter's '88 signature. At this point, I did have the good point to say, look, if I'm going to try and control this, I need to own the copyright. So I actually got John I paid him $1,000 and got him to sign a thing saying he had done this for me as a work for hire, and I actually filed that with the Copyright Office. I have some of those artifacts towards the end of this talk. All right, anyway, this is the original picture. It's still hanging in my office behind some glass that protects it from UV. Of course, it was what we wanted to use on our textbook. Now, this was the very first one that we were doing. We were doing it for Addison Wesley, which was this highbrow publishing company. None of the authors had ever done a book before. And we come and say, we want this on the cover. And they're like, you want what? And so we, no. The answer is no. But I was talking to somebody, and they said, look, you as the author actually get some control over your book. And if you insist, in the end, they will cave and let you put that on the cover. And so we insisted. They caved. It went on the cover, although you'll notice that the signature was missing when it gets to the cover. And of course, that book sold like 50,000 copies. And so the person that was actually our editor there, he was fairly new at the time, but he had got one of my shirts with that picture on it and wore it into one of the company meetings, where everyone else, of course, is in suits and ties, but none of the rest of them had gotten anywhere near 50,000 sales, so he was forgiven. All right. Yeah, here we have the actual cover of the book, and you can see that the John Lasseter's signature has disappeared out from underneath the demon here. And also the orb isn't there, and I mean that's somewhat for stylistic reasons, but also because AT&T was objecting to us putting Unix in there. So there's a shadow, and it's not exactly clear why there's a shadow since there's no light source in the picture, but it must be black light that's coming down off the black background there. Okay. So naturally, there's been lots of spin-off things. This is a stitched version that I got made to do with polo shirts. In fact, there was someone, at least yesterday, wearing one of these polo shirts, which they must have, had in a deep vault somewhere. Anyway, when I got this done, the person that did it for me it gives you a stitching pattern, which you then turn over to the shirt people. And it turned out that it had 33,000 stitches. And they came back to me and they said, we can't do more than about 32,000 stitches, so you're going to have to cut down on the stitch count, because apparently the machine they were running on had 16-bit sizes or something. Anyway, so I went back to the artist, and so she just strategically removed some of the red stitches to, get it down to whatever the count was that they had. They said it's some really weird number, like 32,700. We're not quite sure exactly what. I said, I can guess. It was also used in a number of other cases. Down in Australia at that time, they had the Australian Unix Users Group, AUUG, and their spring, September, they would have a big countrywide meeting, and then in the fall, they would, which was early, January, February, March kind of time frame, they would have state-by-state conferences. And so they organized it so each of the state conferences was 1 week apart. And for those of you that know Australia, what are the 8 states? So anyway, I had to trip all the way around all of the states, and you'd think they could sort of work it into an order like this, but it wasn't. It was like, Melbourne, up, Darwin, now out to Perth, back over to Sydney, no, yeah, it was. I had a lot of flying. Luckily, I was able to buy a ticket on Qantas that was like all you can eat flying for 2 months, and I made good use of it. All right, so anyway, they made these shirts, and so again, another one that got added to my collection as I went putzing around Australia. And I quickly learned that I was one of the few Australians that had actually been to every capital city of the country, which I later managed to do in a car, which was a bit longer of a task. Okay. Again, lots of other sort of fun shirts that people came up with, and you want the shirt? Fine, I get a copy. So this is BSD skewering MS-DOS, which was the competition at the time. So FreeBSD finally comes out, and they want, of course, to have a shirt. So I take the original one that I had, and then I just added the FreeBSD logo up at the top and the slogan at the bottom, which is "The daemon is free." And you'll notice John Lasseter's signature appears when I use his artwork. And in fact, John Lasseter was the person who came up with the first Toy Story. He was the director of that. And so suddenly, his name is known. So, oh, John Lasseter, yeah, he's an important person. All right, and then of course there is the classic from the original distributions. This is actually the first, 2.1 was the first version of the FreeBSD distribution from Walnut Creek that had this picture on it. So there were earlier distributions than this, but this is the first one where this piece of artwork appears. And again, requirement that the signature of the person that did the picture has to be on there. I got kind of snitty about that after a while. Okay, so now time rolls forward, and we're getting ready to do the next edition of the BSD book, and of course we want to have another daemon, a daemon picture. We can't just stick with the same old thing forever and ever. And so I wanted to go back and get John Lasseter to do another piece of artwork for me. Well, by this time, he's a big muck-a-muck at Pixar, and he's in the middle of the next film that he's working on, so he's like super, super busy. But I do get nominally his agreement to do it, and he did some sketches for me. I said, I wanted them to be more dynamic, not just sort of standing there, have him doing something. And so this sketch is like, all right, he's going to be running, and he's going to be like chasing the orb and trying to spear it with his Trident. And so I said, yeah, that looks good. Let's go with that. And so then the next step, of course, is he has to actually draw it. Well, John by this time is partitioned behind, a secretary, so you can't get to him, and you can't email him, and you can't phone him. But and getting to his secretary, if you just call or email her, it didn't work all that well either. But Pixar was not that far from my house, and so I would just drive there, and you could just walk into the building, none of this badges or anything. So I just walk into the building, go to her office, and say, oh, hi, how's the thing going? Is John going to be able to do it? Our book is, we're going to need it in the next month or two, so, we're hoping that it could get done sooner rather than later. And it always helped to bring like chocolates or something, to just sort of lubricate the system. And so at that point, she and I are sort of ping-ponging back and forth about once a week. And finally she says, okay, he's ready to do it. I've got all of his pens out and the inks and the paper and everything's ready to go, and he's going to do it. And he's going to do it. And he's going to do it. And then finally, I get, I'm like down to like a week or two before I have to have it. And she says, he's done it, you can come and get it. And so I go in to get it. This big bunch of flowers on this one. And so she says, it was really odd. I had it all set up on his desk there, and he sat down at his desk, and he picked up the pen, and he looked at me kind of quizzically and said, I haven't drawn an animation cell in 5 years. I don't even know if I still know how to do it. And then dipped the thing, sort of hesitated, and then color. Said 10, 15 minutes, it was all done. So that then was this picture. Oh, so John Lasseter 94 is the signature on that one. And sure enough, he's racing along, chasing the glowing orb. And so here I have it, and I send it off to the textbook folks, and they put it on the cover. Notice this time, John Lasseter is important, and they know who he is, so it's okay for his signature to be there. But more to the point, you'll notice that the glowing orb's not there. He's chasing something, but no glowing orb. And I said, you got plenty of room. What happened to the glowing orb? And they said, have you looked at that picture, Dr. McCusick? That's a sperm cell. We can't put that on the cover of your book. So, okay. So it's there. If you look on the end of the book, he also appears there. No glowing orb. Nowhere to be found anywhere in any of the stuff. That's what you have. Okay. And we were asked, did you order the names so that the tail could fit like that? And it's like, no, that's just what we did. Okay. So naturally, I got a stitching pattern done for this one. And this time, I told them in advance that it had to be less than 32,700 and something stitches. And so I went back to the people, and the artist complained about it, but made it happen. And I went there and I said, that 32,000 limit's really a problem. Like, oh, it's not an issue anymore. Don't worry about it. It's like, oh, now you tell me. Okay, so anyway, I had shirts made with that. This was the printed one. And this was now when we were starting to make BSD freely redistributable. So we originally did what we called Networking Release 1, which was just the TCP stack and the TCP-related utilities like FTP and Telnet and so on. And then the next step was to see how much more of the system we could release. And it turned out we could release nearly all of it with the help of Keith Bostick, who would go to Usenix conferences, and we'd have these birds of a feather session, and he'd get up and say, I need this, this set of utilities rewritten, rewrite it and get your name in lights. And so, easy things like date and, cat and things like that got written fairly quickly. But we said, Keith, that's, you keep working on that. Mike and I were in charge of the kernel. And And so at some point, Keith comes walking into our office and says, well, guys, I've got half the utilities. How's that kernel coming? Well, we couldn't get up at Unix and say, hey, rewrite the kernel and get your name in lights. I mean, just looking at what Keith would do, someone would send in something like cat, and Keith would just completely rewrite it from top to bottom because it was usually really poorly done. But he'd always just leave their name. I said, well, Keith, why don't you at least put your name on it when you've done this much work? He said, no, 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 I don't want my name on there. If the lawsuit comes down, it's their problem, not mine. Say, oh, Keith, there's not going to be any lawsuit. What are you talking about? Anyway, we had to figure out a way of determining what in the kernel was from the original Unix and what was stuff that we had done. And how do you possibly do that? Well, again, Keith came to the rescue. We put the original 32V kernel through the CB, C beautifier, so it puts it sort of in a canonical, crappy-looking form. And then we did the same thing with the BSD kernel, and then we built an inverted database. So the database was every line in the original, and for each line in the BSD, we just look it up and see if it appeared there. And of course, brace on a line by itself and a lot of things on the line by themselves would match. But if you would get a sequence of 4 to 6 lines where it matched, then you knew that that was probably something that was a problem. And so just as an example, when you do something where you need to look up a PID, and so what we would do, I mean, the way it worked was, it was a linear list of the process entries, and you just start and you'd walk down the list until you either found it or you got to the end of the list, and then it didn't exist. That was fine, when the original process table was 16 entries, so how bad can it be? But as time went on, we started having more than 16 entries in the process table. In fact, it wasn't a table anymore, it was just allocated structures. And we were doing a linear search at this point, it's probably several hundred every time someone did something like a get PID. And so we're like, well, that linear list is the old code, so we'll just put in a hashed lookup. Because first of all, that'll be better, and second of all, it won't be what 32V did. And so we ended up making a lot of changes of that sort, and by the time we'd done all that, there was only about 6 files left that had much of any common code left. And it would not have been that difficult to just do those last 6 files, but we were, oh my goodness, I only have 15 minutes? All right, I'll finish this story and then we'll plow through. There were only those 6 files left. We could have done them, but we were afraid that if we released a full kernel that AT&T would get upset with us. So we just released those 6 as prototypes, which of course people very quickly filled in for themselves. Bill Jolitz in particular did the first of that. So, okay, that would have probably been okay, but then this company called BSDI came out, and they had a phone number, 1-800-ITS-UNIX, and they had advertisements where things like 99% off the cost of AT&T's Unix, and AT&T did not take well to this, and so a lawsuit ensued. And I'm not going to go through the whole lawsuit, but there were some pictures that were associated with the lawsuit, and I'm going to talk about those. I hired another artist, Carol Peel, to do a couple more of these beastie things to put on T-shirts. So this one, the T-shirt was Net2 USL 0. He's slam dunking the Death Star, the logo of AT&T, in this particular picture. And then the other one that she did for me was this one where he's standing on the top of the world wearing my Birkenstocks instead of the regular ones, and he's just skewering the Death Star, so I got it, and it's deflating on his trident. And so, of course, there were shirts that got made with this, and the slogan on that one was, "Free the Berkeley 4.4," because that was the distribution we were trying to release at that point. So the Beastie got used by all of the other projects initially. None of them still use him today, but because marketing worldwide, he has bad connotation, et cetera. So but I just put in some early pictures. So this was an early NetBSD daemon usage, and this was OpenBSD early daemon usage. Even the FreeBSD Foundation had the daemon. He's in a suit and tie because he's corporate. And then there were just a bunch of other sort of fun uses. So this was the BSD marketing daemon. Inevitably, there would be something bad in front of him that he was smashing. I just chose to show just the picture of him. The power to serve, this is another one that I loved. Just walking around because it was a server-based operating system. Here is the documentation daemon. The FreeBSD News was a thing that was done for a while, so this is the daemon sitting at his desk and reading FreeBSD News. Here we are. These are Walnut Creek CD-ROM releases. So FreeBSD 2000, which was 4.0 at that point. Oh yeah, so this is the copyright assignment, so this is Dear John letter to John Lasseter, and really the only thing that's interesting in this letter is his signature at the bottom saying it's a work for hire, and my signature saying I accept it, and here's your $1,000. And so, of course, the thing is then you file with the Copyright Office so that you actually have the copyright. And so when people do bad things, you can go complain to them. And they mostly ignore you because they know you don't have the money to sue them. But nevertheless, it makes you feel better. OK. So just a couple last things I want to talk about. I've been asked several times at this conference, that textbook of yours is getting kind of long in the tooth. How about you, when's the next edition coming out? It's a long story, and I'll just tell the condensed version of it, but our original publisher, Addison Wesley, is winding down out of doing printed books. They just want to do online things and tutorials and stuff like that. So they still do a few printed books, but not very many, and they weren't particularly interested in doing our book. Or they said, well, go ahead and write it, and we'll decide what we want to do. Yeah, right. So we said, OK, we at least released the copyright back to us, because we'd assigned the copyright to them to do the publishing. They said, sure, we'll do that. And then we said, and when it's written, we'll let you know if you want to do it, print it or not. It took them 2 years to get a lawyer to write a one-page thing that they could then get corporate to sign. But they did. And that happened at the beginning of this year. And so then we say, OK, now who are we going to get to publish? Well, there's 2 obvious ones, O'Reilly and No Starch Press. And O'Reilly's like, yeah, maybe, whatever. And No Starch Press says, yes, 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 we want to do it, really, we want to do it. So we decided to go with No Starch Press. Now, up to this, the first 4 editions, I have been responsible for writing most of the book. George or Mike Carls has done the networking stuff, and in the recent editions, Robert Watson has done the security chapter, but I just did all the rest. Furthermore, it's in TROF, and there's this incredible macro package that goes along with it. And so what we actually give to the publisher is camera-ready copy to be published. And so when we went to No Starch, they said, well, LaTeX is really what we're all set up to work with. And, we can figure out TROF, but it'd be a lot easier in our workflow if you could just do it in LaTeX. Well, the second piece of this is I'm realizing that I'm not getting any younger. So I'm in my 70s now. By the next book, I'll be in my 80s, if I'm even still walking on this planet. And so I won't be, I can't be responsible for writing all of this. So my second goal was to sort of pass it on to other people and make it their problem for future editions. And so what I've done is, you'll see a list of fairly familiar names. Yep, I get it. 3 minutes, I get it. OK, so what am I responsible for? The preface, the history, The fast file system chapter, I'm still going to do that, and cat herding, which is to say making sure everybody else gets done what they need to do. Okay, so we have got George is still going to be doing the networking. Robert Watson is still doing security, but we brought on John Baldwin for kernel services, process management, and virtualization. We've got Warner Losh doing I/O systems, devices, and system startup. Mark Johnson is doing memory management. Alan Jude is doing ZFS. And Rick Macklin is doing NFS. So as you can see, we've got a set of people other than Rick Macklin, who's sort of my age. We've got a whole set of considerably younger people that are doing this. They all know LaTeX because that's what they grew up on, and they look at TRUF and they go, what is that weird stuff? So the first step was to convert the existing TRUF to LaTeX. And so far, there's been just over 200,000 text changes committed, many of which I wrote like a big awk script that did a whole lot of stuff, and John Baldwin's also written a lot of scripts that does stuff. So we're kind of down now just to the final niggly stuff. So I imagine in about another month, each chapter will be able to build on its own, at which point I'm going to start nagging people like Warner and Mark and Alan and Rick and so on to say, okay, your chapter's ready, get to work. You have 3 months. Well, that was the schedule we were supposed to have. We obviously won't have that schedule anymore. But my hope is that sometime by late next year, we will actually have the next edition of the book out. Okay. So, just to sort of finish up here, I ended up taking this talk, and I made this little composite set of images. And I went to Liberty Puzzle, which is based in Boulder, Colorado, and they make these laser-cut puzzles. And I even brought the pieces for the top right corner, which I conveniently forgot to bring in my backpack, but maybe sometime later today I'll get it and set it up so you can sort of see how they look. But it's a very cool thing. John Baldwin liked it enough that he actually bought one, so you can ask him what he thinks of it. And I also have a video on my YouTube channel, which is how to put it together in 4 minutes or 5 minutes, something like that. So, if you just want to see kind of what it looks like. All right, so with that, I will take any questions in my remaining 7 seconds. So, anybody got a question? Person with microphone down here. Down here, there's
I didn't see you, I'm sorry.
Obvious question, which daemon will be on the cover of the book?
Which daemon will be on the cover of the book? That is a matter of some debate. It seems that No Starch Press has sort of a theme, just like O'Reilly does with animals and other weird things that they want to put on the cover. So by default, we're going to get some random animal. However, I am lobbying to get some variant of the demon put on the front cover. But we'll see how that ends up going. Maybe it'll be the demon, battling with some mythical dragon or something. Okay? Anything else? All right. Well, I'm around. Feel free to tag me, ask me questions, etc. Thank you very much.
glad there are a couple of people who are interested in these sort of things, as some who have been to my talks before. I mostly talk about operational aspects. I'm not much of a coder. Just a really short introduction. I'm working with Punkt.de in Germany since the company was founded. I'm one of the owners. We started as an ISP, and today what our marketing department came up with is open source digitalization. So we try to help customers with transforming internal processes, but instead of building it all on commercial products, use open source for that. We built quite some know-how, for example, in identification, authentication management with Keycloak. We do a lot of PHP portal applications. And whenever we can, and whenever we host it, we run it on FreeBSD. We have 36 employees at the moment and 2 office locations. I myself, as I said, I'm an owner and co-founder of the company. I do FreeBSD since 1993. And I've always defined myself as a network and systems engineer. So I take products, look what they can do, and then combine products and features in interesting ways to come up with innovative solutions. But in recent years, I've come more and more into actual coding, contributing to OpenSense and stuff. But still, mainly it's how to manage FreeBSD systems, not much how to code FreeBSD kernel stuff or so. We run about 100 physical servers with over 1,200 customer jails. So our standard hosting product is a jail. This jail, we name it the Pro server, contains everything and the kitchen sink. So there is Apache, Nginx, Caddy, what have you, MariaDB, Postgres, Java, PHP, Perl, and then the customer just picks what they want to run, service enable, service disable, whatever. And we take care of all the updates, maintenance, backups, restore, rollback, and stuff like that. Our challenge, we've run our own data center since 1998, and currently we run it at Telehouse in Frankfurt. And part of the management layer 2, we have already outsourced to a friendly company whom we work with since also 1998 or something about that. Plusline, they're great. So they do all the layer 2 and uplink and electricity for us, but we still used to buy servers, deploy them, put them in the racks, install FreeBSD on them and stuff. And that's becoming more and more painful because as a small company, if I order a server, it takes 2 weeks to get a custom configured server from some of our reliable suppliers. We have to stock spare parts. We have to either drive to the data center or have some other operator on duty to do hands-on maintenance. You have the lifecycle management. You switch out the server platform, and when you have a new generation, completely new generation of hardware, suddenly you also have a whole stock of spare parts that you can just throw away or sell at eBay or something. So hardware is not fun. Can't we virtualize it all the way? So, and hosting is a commodity nowadays. You can buy a dedicated root system with your operating system of choice about everywhere. So what we tried is, how far can we push this? Because we need, of course, we have customers with special needs, with high availability configurations, with local load balancing, with dedicated local firewalls, with private VLANs and everything. So the question was, can we do this in a commercial environment like provided by Hetzner in Germany? This, Michael said, is this going to be a Hetzner marketing talk? A little bit at the first, and then we'll go into the technical details, and it won't be, hopefully, anymore. So why did we pick them? They're located in Germany. They're reasonably big and well-funded, so I hope they will be there in the next couple of years. Located in Germany, so by law they are GDPR compliant, which is important for us because we need to be too. And they have multiple data center locations. Products are virtual PC, so cloud or dedicated server. They call that product Robot. Intel or AMD, your choice. NVMe or spinning Rust, your choice. Gigabit uplink flat included in their dedicated server offerings. electricity included in their dedicated server offerings, and they can do surprisingly flexible modifications if you order them. If you order a stock server just under configuration, they will deliver it next business day. If you say, okay, I need 2 more network interfaces and a private wire and stuff like that, it will take them a week or so. That's good. One example about the pricing, AMD Ryzen 16 core, 128 gigs of RAM, 2 NVMe SSDs, uplink 110 per month. That's sharp. And so we started moving our business from the private data center and from our servers whenever a server was outdated and needed to be replaced, instead of buying a new one, or when we got a new customer and a new order, we deployed them at their DC. They have a rather nice UI for managing all that stuff. So this is our current situation, 45 or something systems. And this thing has power management, inventory management of reverse mapping and stuff. Unfortunately, but I'll get to the technical details later, so just drop that sentence, back to topic. Okay, all dedicated servers to Hetzner, install FreeBSD, keep our own private cloud, Ansible-based infrastructure, and profit, hopefully. And it all starts with installation. When I get a new system from them, as I said, they have great web portal management, power, reset, offer a rescue system, of course Debian-based. And then we stumbled onto 2 issues. KVM only on request. So contrary to cloud systems, the dedicated servers have no IPMI, no console, no nothing. You can order it and they will provide it for free, but it will take from half an hour to 2 hours, depending on demand. And then we will have it for up to 3 hours. So that's not quite as convenient, but still workable. And they have officially no FreeBSD support. So what to do? We have dpenguin.me. I guess one could talk an entire presentation about how that works. This is also the URL of the website. Dpenguin.me is a script that bootstraps an MFS-BSD image in KVM. So you boot into Hetzner's rescue system, which is Debian-based, then download the dpenguin.me script. It boots FreeBSD in KVM, maps all local block devices it finds into virtual disk from first to last sector. And then you can run BSD install just the regular way and install FreeBSD. This is just awesome. And it works with other hosters too. So quite a thing to note and to keep in the back, in the tool bag for future installations. The good thing about Hetzner is they are not overtly hostile to people running other operating systems. They are completely cool with us running FreeBSD, and if I open a ticket and say, all right, we have this hardware issue here, they don't go the Dell or Lenovo way and say, you're not running our supported OS, and please run this diagnostic tool first, et cetera, et cetera. I'll send them the kernel demessage output that says, look, this NVMe disk is broken, and they replace it, no questions. So they're cool with people running whatever they want. They just have no internal FreeBSD know-how. For setting up a system remotely that you will then reboot into a live system, I found this nifty trick, and I don't know if this is really documented anywhere. I stumbled upon it by reading the source in the RC system. We have an ifconfig_default for rc.conf. That's awesome, because when I install from the virtual machine running inside Linux, I don't know what the names of the network interfaces will be. And sometimes with them it's IGB, sometimes it's IGC, sometimes it's IX, we get all sorts of mixed hardware depending what they have on the shelf. So this does the trick and plain works, bringing up the machine. So what's an uplink in the data center look like? Of course, we have dedicated servers, they nail down the environment for their customers as much as possible. You always get with each server, you get a /64 IPv6 free or included. And you can have an optional single IPv4 address for a pretty small fee if you need it. Sometimes we do, sometimes we don't. And then if you need IPv4 addresses for hosting, and I'll show in some of the next slides how to save IPv4 addresses if you just host web applications. Then you can get /29, /28, /30, but fees are increasing, so it's not astronomical, but the IPv4 addresses are worth real money now. They nail down in the switches the MAC addresses, probably use static ARP for IPv4. I have not tried to find out how they do it with IPv6, but they just route the entire /64 towards your server's MAC address. And that's that. You share a /26 or sometimes a /27 with other customers, and you can see their ARP requests in IPv4, but that's not a problem. I mean, this is the outside interface of your infrastructure, so it's considered internet. Yeah, that's that. So firewall accordingly, or lock down your services accordingly. This is public network. You have a static IPv6 gateway. It's a linked local address. I consider that best practice to have linked local default gateway addresses for IPv6. I really like that. And it's the same for every server and every network. It's always FE80:1. So that's easy. In our own data center, this is from my Pro Server architecture presentation from Paris. We just bridged all the VNet jails directly to the network and gave them public IP addresses. In Hetzner, we can't do that anymore because we only have one MAC address, so we cannot use VNet interfaces with different MAC addresses. So what we do is we just disconnect the bridge from the physical interface and have the host be a router. So the jails are routed through the host machine for IPv4 and IPv6. Yep.
Why are you bridging the different customer jails together instead of running the host, which is already a router, as a router for each jail? Why bother with bridging?
Because VNet and IOCage do that and don't do routing. Tooling limitation. We did not, as I said, I'm an operator. I combine tools that are there, and at the time, IOCage, Bastille did not yet exist, was the most advanced and IPv6 and multi-protocol and multi-interface capable jail manager around. So we picked that. We have some vague plans to refactor that, and I would go to plain FreeBSD jail.conf, because now we have the jail.conf.d and we have one file, and I really liked your presentation about it. But at the moment, we are limited by what IOCage can do. So, and you see that jail over there to the left, that's a gate 6.4. So conserving IPv4 addresses, we do NAT 6.4. But let's have a look, let's get a little bit technical for a moment, because there's also an interesting nugget in here. We rename the physical interfaces to a standard configuration for all our hosts. So the uplink is always INET0, and then you can see a /26 IPv4 address. That's what Hetzner gives us, and the default gateway is also an address in that particular /26, so that's Hetzner. Then we have the bridge. We name the bridge jail0 because that's where all the jails are connected. If we have IPv4 for the jails, then we have a /29 at the very least, because that's the smallest network that makes sense. And then we have an IPv6 address, like something prefix 2/64. And the interesting nugget that's hiding in here, we get 1/64 from Hetzner. Just a second, let me finish first. 1/64 from Hetzner. But the host itself also needs one IP address out of that /64 on the external interface for egress, for downloading packages, for NSX, for DNS lookups and stuff like that. And it has been common wisdom that you cannot put IP addresses v4 or v6 from the same prefix on two different interfaces. When IP NCP was first invented, the first idea was that the IP address should be a node identifier. But at that time, all links were point-to-point links. And when Ethernet was introduced and we got broadcast domains and we got bridging and all that stuff, then it was quickly decided that it should be an interface or broadcast domain identifier, and you should have different networks for different interfaces. But you can, in FreeBSD, actually assign an IP address from the same prefix to a different interface, as long as that interface is, e.g., a point-to-point interface, or one with a link local default gateway, when you pick a 128, or in the case of IPv4, a 32 net mask. So you can borrow a single address from that prefix that is configured on the bridge.
Have you really configured unique locally assigned IP addresses, or did you replace the global IP with?
I replaced the global IP with that beef.
Okay.
So these are all global unicast addresses. The 1/64
ULA address.
by accident. That beef is just the generic placeholder, at least in my presentations and historically. So no, that's a global unicast address and a global unicast network, and we borrow a single address for the host itself with a /128 net mask. That's similar to what in Cisco IOS would be IP unnumbered, and then borrow an address from a different interface. I have not tried if you could actually use the same on both with that /128. Now NAT64. So IPv4 addresses are expensive, and most customers only run web applications. So they're interested that their customers can reach their applications via IPv4 and IPv6, but the jail does not necessarily need to have a globally routable IPv4 address. So we use an SNI proxy in that Gate64 jail for that, and then some IPFW magic in the jail. This is the Gate64 part. So we allow 80 and 443 to the external IPv4 address of the jail, of the Gate64 jail. And we allow TCP out to any target that's in that IPv6 prefix to ports 80 and 443. And then we just, for security, because we don't need it, we deny everything that is not needed. We deny the jail to reach out to other websites on other servers. And then IPFW has this nice NAT64 function. So you can create an IPv4 prefix and then translate everything that's going out from the IPv6 prefix to any of the NAT64 IPv4 and IPv6 addresses. We NAT to IPv4, and everything that's coming in, we NAT the other direction in. So is everybody familiar with the concept? If an IPv6 host, IPv6 only host, asks for a DNS record of quad A for a system that does not have any, and you have a special NAT64 DNS server or DNS64, then the DNS server will answer with a fake quad A record in this FF9B prefix range, and then the IPv4 address will be embedded in there, and then a NAT64 gateway can translate IPv6 to IPv4. So that's how that works. And in the jail part, and I think this is quite clever, we have the outgoing route. So we have the NAT64 prefix, and we route this towards the Gate64 jail so it can get translated. And then in Nginx, we have two additional hosts on ports 87 and 57. I don't remember how we came up with these numbers. And they have the same configuration as the production web service for IPv6. But additionally, we activate the proxy protocol. Proxy protocol enables a web server and a proxy to transmit stuff like the host name in the query and stuff like that. And whenever we get a connection on our IPv6 address from the proxy system. On port 443, we instead translate it to port 57. So we get in Nginx the proper proxy protocol aware server entry. Yes, Jan?
You deal with HTTP2 clients who reuse the TCP connection to talk to different host names.
Wouldn't work. Haven't noticed any so far. So the flow of the connections is the SNI proxy. An SNI proxy is a thing that can do TLS to TLS. It just does the server name identification negotiation at first, and then relays the TLS connection. And so we get a request on port 443 to the SNI proxy. The SNI proxy knows the host name. It can look up the IPv6 address for the target host name in DNS. So that's why it's absolute mandatory to have quad A and A records for the final destination. Then it relays the request to the IPv6 in the jail, and then our IPFW magic translates that to port 57, and there we have the special server configuration that speaks proxy protocol. Because on port 443 in the jail, we have a regular server that answers all requests that just come via IPv6, because it's a web application that's globally reachable. So there is of course a server listening on the IPv6 address. So this is the standard part. We've been doing this in our own DC. This is one host up to, say, 100 or so-ish jails. Runs well, and the customers are really happy with the way we do the updates by simply exchanging the entire image that is underlaying the jail. We shut down the jail, switch the nullfs mount points. We use nullfs still, and then boot up the jail, and we have an instantaneous, with 20, 30 seconds downtime, update of each jail. Now, pushing infrastructure needs a little bit further. Hetzner allows you to order additional network interfaces for private connections. Can be a cable or an unmanaged switch. For that to be possible, the servers need to be in the same rack. So if a customer wants to, they don't do cross wires, cross racks, but they are really flexible as long as you stay in, as long as you stay in the same rack. And you can reserve rack units for a reasonable monthly fee, single digit something. So if you're planning ahead for growth, they say, okay, please 6 rack units for servers for this customer. And then you know you can always interconnect them. And then you add a bridge, you attach jails, and you have a private interconnect. As I said, we use I/O cage. So the setup of the interface is nothing specifically tricky. We just have an, I see, sorry, I forgot the bridging code. But just, we have this IGB1 interface, and then we put a bridge on that, and then we can connect jails. To connect jails to more than one interface, in IOKH you have this interfaces variable, and then you can say, please, VNet 0, connect to that bridge, VNet 1, connect to that bridge, VNet 2, connect to that bridge, as much as you want. And then you can get set the addresses in the syntax like this. So for VNet 0, we have that address. For VNet 1, we have that address, etc., etc. That one is a unique local address, the second one for the private network. So, and this was one of the first requirements when customers said, all right, big enterprisey customers, we need a relay from your pro server infrastructure into our own data center, and there must be a dedicated firewall, and it must speak IPsec because enterprise. Okay, so we put an OpenSense on a dedicated system at Hetzner, ordered a second network interface. Then we have the pro server host who also got a second network interface, and told Hetzner, please just run a cable. And that works really well. And now to get really fancy, they offer something that's called vSwitches, virtual switches. And this way you can create not only limited to a single rack, but you can create over their entire infrastructure, physical servers and cloud instances, flat networks. From a customer or host point of view, it's based on VLANs. So you create a VLAN on your uplink interface to connect to vSwitch. You can have up to 5 vSwitches per server, up to 100 servers per vSwitch. So that's quite a bit of breathing room. The vSwitch itself is free. If you need public IP addresses because you use the vSwitch for a public internet-facing part of your infrastructure, of course, the public IP addresses are available for a fee. Internal traffic doesn't cost a thing. External traffic, 1 terabyte included. And above that, €1 per terabyte per month. Quite reasonable. I think we have never exceeded the 1 terabyte limit so far for any customer. And the vSwitches support multicast. Yay! CARP, we can do high availability load balancing open sense clusters in their DC. And that was our first installation for a customer where we used the vSwitch at all and were tested extensively if CARP and multicast would be supported and if everything worked. So as you can see, these OpenSense boxes, they now have a 1 gig uplink, which comes with every server you buy. They have a second 1 gig interface with a cable for the PF sync and the RPC for the clustering of the 2 nodes. And they have a third interface. You can order up to 2 network cards at Hetzner with 10 gigs connected to a private switch. And then we have all our hosting servers. The customer currently runs 6 and plans to grow up to 10, also connected with 10 gigs to the same switch. And then we can run public IP addresses, IPv4 addresses with CARP on that external virtual switch and have a really highly available OpenSense configuration, which of course is not so much about the availability in terms of entire host crashes or anything, but I can do updates without interruption. It's a second. We lose 1 ping or 1 request or something like that if we update the OpenSense cluster 1 node at a time. That's really quite nice. And what we do in our Pro Server and Ansible infrastructure is that we use the standard uplink of the Hetzner hosts for management. In that particular case, they are IPv6 only, which is enough for us. We run dual stack since 2001, 2 or something, entire company. And then to this backend in the private network, it's IPv4 only because the customer likes that way, and they're a little bit old-fashioned. And then we relay IPv4 requests through the OpenSense via H8 proxy to the individual nodes and can do all sorts of replication and high availability and stuff in there. Second example is the most complex I've built so far. This is our new shared infrastructure. Our product is either a dedicated machine, and then you can put as many jails on it as you like, but we manage the jails. You just say, okay, I need 1 more, and then we deploy it from Ansible and then tell you the IP addresses so you can log in. Or if you buy a shared Pro Server, you get a single jail. The customer regularly does not get any access to the hosts. So for customers who run only a single jail, we also have the requirement, can't you do HA replication, at least with manual switching in case an alarm goes off because an entire machine fails or anything, but at least something, we have that in the book of standard requirements and stuff like that. And in former times, we always said, well, if you want HA, you need to buy 2 dedicated machines. But of course, sometimes the project just doesn't have the budget for that. So after a little bit of planning and internal talks, we came up with shared jails. So many customers are supposed, this is quite new, so we have 5 or so on them yet. Now, many customers are supposed to share these things. We can deploy standard jails. That's the link at the very top or at the very bottom. Just the architecture I showed you with the bridging and the routing, and you get a public IP address. Or I can give jails, or on that 10 gig link, which is a cable, I can create as many VLANs as I need, 1 per customer, and then connect their jails there, and they have a private link for replication and whatever mode of high availability they want to do. And then for the uplink, we go into a vSwitch, which goes to the OpenSense cluster. Again, there's a simple cable for sync and RPC, and then we have CARP as the, say, IPv4 default router for all the jails on these hosts. And then another vSwitch, which goes to the internet with IPv4 and IPv6, and again, CARP. And all of this works flawlessly and very smooth. I'm quite satisfied with how that is running. We don't have any servers so far with more than a 1 gig uplink. We just don't have the bandwidth requirements, and the vSwitches are not limiting that bandwidth in any way. So 1 gig of throughput, no problem. I have not yet had the opportunity to test 10 gig uplink and then putting it through a vSwitch. Host configuration again, that easy. We have the regular network interface stuff, and then you simply put a VLAN on your uplink interface. At Hetzner, vSwitches can only be connected to the uplink of the host, and then put additional cloned interfaces in there. So again, I have here a private Prev0 named bridge on that VLAN that you can see in the second paragraph. In this particular case, the host itself does not have an IP address on that particular VLAN because it doesn't need one. We just connect the jails, and each jail's got an IP address. So for us, trying how far we can push the envelope of what we can do, and if we are as flexible as in our own DC, I must say yes, indeed. And I mean, Hetzner also has a custom everything department. You can buy a rack and consulting and then service to your specification with network cabling and everything, switches and what you need from them. They are a professional supplier in that regard, but we wanted to try and stick with a simple standard product that we can order and manage ourselves through their web console. Not least, of course, for cost reasons, because the custom stuff involves humans working on that, and they want to be paid. And in their standard control center, everything is automatic. So our conclusion is, yep, great success. Specifically, because of scale, we have far better mean time to repair and stuff like that. Even if you count in the overhead that when I get an alarm, I first need to open a ticket with them. They have a 24/7 phone hotline, and they have reaction times that can go up to 1-ish, 2 hours, but not more. But they have inventory. And if I say, okay, this server has crashed the 3rd time in a couple of days, I suspect the main board has this and that issue, and provide some D-message output or something. Again, they don't insist that I first run a Linux-based test suite or something. They simply swap the thing, and we're up and running in no time, very, very quickly. So that's definitely good. So I promised I would not do too much Hetzner marketing, but I have one more thing. I contacted them, asked them if they wanted to possibly explore how they could expand their FreeBSD audience, maybe start to support FreeBSD, maybe send an engineer so we could do this talk together. They friendly declined, but Here's a coupon code in case you're interested in trying their offers. Take a picture with your smartphone. That's worth 10 euro, and it's valid 50 times or 49 because I had to try it at least once. Yeah. You need to activate this until end of tomorrow. Yes, that is short notice. I don't know why they did it that way, but once you put that into your account, you have these 10 euro to spend over the next 3 months. So if you like it, take a picture and that's it. Okay, questions? None? Nice. Should you come up with some in the future, or should you need some help? Of course, I'm always willing to give away advice and communicate and everything for free via regular channels. If there is a customer and a budget and you need serious consulting from us, then of course my company is also available. It's my email address. The handle is from Blue Sky. I moved off of Twitter 2 years ago and don't regret it. And Blue Sky is a fine place if you like that sort of microblogging service. Thank you very much.
And without privileges, because as we can see, as you probably know, it requires privileges in traditional Unix settings, so we're going to see why and how we would like to do that without privileges. So, since I'm relatively new in the community, I just wanted to have a small slide to introduce myself. I'm not going to read all that. Basically, I've been using FreeBSD for more than 20 years, personally and in some companies. And I've been gradually involved with the community since a few years, 4 or 5 years, and actually now working almost full-time on FreeBSD since approximately 2 years. So some other work I've been doing that you might have heard about. There again, I'm not going to talk about all these things, but generally I've been working on some security stuff, security policies, hardening them, working on hardware mitigation sometimes. More recently, working on vnode recycling as well, as we had problems causing live locks between 14.2 and 14.3. I'm doing some work also in the scheduler, and more recently working on trying to support hybrid architectures with performance and efficiency cores. So this is a kind of longer project. And yeah, some fixes for graphics and DRM support for AMD GPU cards if you have had freezes, intermittent freezes in the past releases. We hope now it's completely fixed. Obviously, there are lots of other problems, some hardware that is not supported and all that stuff. So I'm not saying everything is fixed, but at least if you had something working but freezing, normally it should be fixed now. And I'm just mentioning as well UnionFS because I've been the author of a proposal 3 years ago. Unfortunately, I've still not started working on it, but I hope that this should happen in the coming months now. So, okay, so let's get back to our topic. So for this talk, I'm going just to recap a little bit how traditional credentials management works traditionally in Unix systems. And then we'll see why we introduced actually this other means that is called MacDo and MDo, and for which reasons, how it worked at the beginning. Then some of the configuration extension I've been working on since a part of last year, actually. And how, with all that framework, how do you actually practically request new credentials? And if we have a little bit of time, I may talk about some of the implementation details that could be of use for you if you intend to implement some kernel module related to security or access control. So let's start with traditional credentials management. So as you probably know, credentials are per processes in Unix. The different credentials are inherited normally by fork. We have, and the credentials consist in different data. You have some user ID, some primary group ID, and then supplementary groups. And actually, the user ID and primary group ID, they come in 3 different variants, which are used for different purposes. There is the real variant. The real variant actually says who is the originator of the action that you want to perform. There is the effective variant, which is more the identity of the actuator, the person who is actually performing the operation, and the safe variant, which is kind of buffer, which allows to switch back and forth between both the real and effective IDs. So, and what is it used for? It is used for reasons that everybody knows, that it's discretionary access control on files. So you have to match. You have to have the good credentials with respect to the permissions to be able to access a file or open it or write it and so on. But it's also used for different primitives that are used for inter-process communication, such as shared memory, for example, message queues, semaphores, whether you're using the old System 5 API or the new POSIX APIs, they all take into account these credentials. And it's used also to send signals. So again, to communicate with other processes, or all those signals are a bit different. And also for resource limits, and for resource limits, what's important is the real user ID, that is to say the person who the program is acting on behalf of. So this is the data, what the credentials are, and this is the API to manipulate them. So actually this API, you can only modify the credentials of your current process. You are not able to inject any credentials anywhere else. Obviously to change your credentials, you need appropriate privileges, which in POSIX jargon doesn't mean much, except that the implementation can do whatever it sees fit. So, but we have, obviously there is traditional behavior there we are going to talk about just in the next slide. And so here is basically here is the API. So you have a bunch of functions to change the user ID or certain variants of them. Same for the primary group, and you have set groups, which is supposed to change supplementary groups, and for some historical reasons in FreeBSD would also change the effective group ID, but we have been changing that for 15.0 actually to be compatible with other systems. So this is the API, and now we are going to unzoom and to widen the perspective. So this is the API, but how is it used actually? So for that, how do we change credentials? Well, usually we start with a privileged process. So you've been root from the start, for example, as init is and launches the different login processes. And then you log in and you will change credentials at that time. Or sometimes you're a regular, most of the time you're a regular user already, and you want to change credentials. And for this, we are using set user ID executables with the owner being root. So when you execute that program, you're going to be root, but that program is going to be careful to check for different things before actually setting the new credentials. So once you're root, then you call the API. Basically, you call the functions I've just exposed, but there is one caveat there, is that you must stay privileged actually to use the API. So, and privilege traditionally in Unix means, okay, you are root. Although in FreeBSD, it's also true, but we have the Mac framework enabling some privileged operations without being root. But usually you have to be root. So you have to change the effective user ID last. Because if you don't do that, you will lose privileges and all the other calls are going to fail. So basically that's the constraint. And now if you wait on again, what do programs establishing credentials actually do? So they do authentication, which is the control the source of the request. They do authorization. Then they spawn a new process, which is going to have the new credentials, because as I said, you cannot inject credentials, so you have to create a new one. And this new one has to modify its own credentials. And to do that, so there is a setup phase where you change different attributes that require privilege, such as resource limits, scheduling settings, for example. And then you change the credentials, as we just have seen. And then, once we have the new credentials, it's almost finished, except that sometimes we fiddle with other attributes that are unprivileged. And then we hand over the new process to the program that we want to execute with exec. So that's the traditional sequence. And that part, that high-level sequence, is not changed by this work. It's really the credentials step that can change. So as example programs, yeah, as probably everybody knows here, the traditional SU that we have in the base system, it's basically to launch a new shell, actually, which is under the new credentials. But it's very simple. It just takes a login name. Then at the other end of the spectrum, you have a sudo, which is kind of the Swiss Army knife of credentials changing program, because it can do a lot of stuff, which can be very useful depending on your needs. So you can authenticate with the closed password. You have fine-grained control on commands also, so you cannot really launch anything with the new credentials. You are limited to a set of programs. You can do full I/O logging, so to be able to control what was done under that temporary credentials, etc. And there's kind of the new kid of the block, which is not that new now, but which is do as kind of intermediate take. Maybe it's closer to SU than sudo actually, but still compared to SU, you have a simple transition rules to say, okay, if you're that user, you can become that other user. You have also some filters on executables, but you can do a full login as in SU actually. So, what is the problem with all that? Well, it can work well. The trick is that all these executables, they have to be set user ID executables to be able to become root, at least temporarily, to establish the new credentials. And while they are root, actually, they are able to call any function of the API without restriction. So that could be a security problem if there is a flow in these programs, if we can inject code in some ways. So, and the problem is that, for example, typically Studio is quite big. It's, if you count its security, the usual security policy, sudoers, it weighs about 900 Ks, for example, on my system, versus SU, which is only 17 Ks, actually, so there's a big order of magnitude difference. So for security auditing and compliance, it can be in problems in some companies. And actually, sudo can load security plugins, so the attack surface is kind of maybe too big for these kinds of programs. So what would happen if they are compromised? Well, you could do basically, this could have catastrophic consequences actually. So that's where MacDo and MDo come into play. Although the initial goals were not to replace sudo or do as, they were more limited. So the goals would be to actually enact these transitions, but without set user ID executables. And it was mostly to support role-based scenario where you have users representing your real people working on your system, and then you have other users representing roles, the different roles they must have, such as, I don't know, web admin or database administrator or what else. And actually, when you're one of these users, you have some roles associated to you, and those that have, for example, the web admin role, they are supposed to be able to actually change users when they have some web admin task to perform. And another role of this was to avoid installing third-party packages as well. So for this reason, it's Baptiste Daroussin that introduced this pair, with MacDo being the kernel module, which is based on the Mac framework. Mac is for mandatory access control. It's basically how we control, how we can actually implement security modules in FreeBSD. If I have a little bit of time at the end of the presentation, I may talk a little bit about it. So it allows some credentials changing system calls to succeed, but not all of them, only those that are authorized by an administrator. And it only accepts such transitions when they are requested by a process launched from a specific executable. That's just an additional security measure, but we will see why also. And so the companion userland program is MDo, and it's the actual program that makes the calls that we have seen before. So initially, the rules for MacDo were quite simple. There was this division between two parts, which has not changed. So today also we have those two parts. The from or match part, which basically says whether the rule is going to apply or not. And then there is a target part, which says, okay, if the rule is matched, you have the right to become this user, for example. And initially, it was quite simple. Actually, in the bottom, you see some example of it. There are two rules, actually, in the bottom, separated by a comma. So the first rule says, okay, if you were user 1001, you can become user 1002. And the second one saying, okay, if you were in the wheel group, you can become root. So that was kind of simple, but effective. And MDo worked like that. The first two calls get PWNAM and init groups, or part of it, the get group list part of it, they would retrieve information from the password and group databases, because you would specify a new user to become, and then we would retrieve from the databases the different groups associated with that user. And then we would set the different groups, so set groups for the second supplementary ones, set GID, and finally set UID, a little bit like the pattern that I show in the introduction. And it had a number of limitations. Actually, you could not set custom groups, so basically you had to accept the groups from the database, or there was an option to actually keep the current groups and change just the user. But there was even more important problems with that approach, is that, so MDO, as I said, is not a set user ID program. So normally these calls, at least the set group, set GID, set UID, they should fail if they are not authorized by MACDO. And the trick is that we have rules to know if we can change, for example, the user ID. So set UID, okay, we know how to check it, but for set GID, for example, and set groups, which are the groups that we can actually authorize? We don't really know. We're in the kernel. Remember, it's going to be checked by the kernel. So in the kernel, there is no password or group database, although we could imagine copying it. So in the kernel, we don't know that. And basically, the first way to do that was just, okay, we are just going to authorize set groups and set GID. So again, in some ways, we trust userland, although we have been doing the rules in the kernel. So that was a kind of weird. And the limitations is that you could not change groups. So that's why I worked on configuration extensions. They mostly concern groups, but everything is a bit tied in this story. So the groups use cases, they are kind of, I would say, more or less well-known as well. So yeah, you can be a member of different groups. That's the supplementary groups functionality. They can be used to allow access. So if you're a member of a group, you can access the different files that are tagged with that group, depending on the other permissions. But it can be used for other purposes as well, although it's less widespread. It's, for example, to deny access via Mac. There is a Mac module doing that. So there is a userland program which works like a firewall, where you can say, okay, this user is allowed to access this file or is denied to access this file, regardless of the actual permissions of the file. It's just based on path. This is something that exists in the tree and works. It's also useful for auditing purposes, because sometimes we log the different credentials some user has when doing an operation. So it can be important to be able to ensure that some user is associated to some group, and that association should not be broken, actually. And maybe more traditionally, the groups, usually they are considered part of some user's identity, especially in FreeBSD, where we have this scheme of, and we are not alone, actually, to have that, where we have this scheme of having a specific group per user. So usually when you're a user, you are expecting to be able to access also all files that are tagged with your group. So these are kinds of expectations that require that the groups you're authorized to become or to be in some ways are tied to your user ID. So you cannot really say, okay, I will authorize someone to be in this group. In general, you have to check for the ID. Depending on the user, you are going to authorize some groups and some others not. So basically the work here was to try to devise how to evolve the rules to be able to support groups. And primary groups and supplementary groups have to be distinguished because they have slightly different properties. For set GID executables, for example, the primary groups can change, but the supplementary ones never change. So if you want to have tags, for example, they have to be in the supplementary groups part. So the rules have to distinguish between the two. So what has changed is that the front part of the rules are the same as before, is the same as before. But the two part has changed considerably, because before it was just a numerical ID saying, okay, you're authorized to become that user. But today it's in fact a list of target clauses, so you can have multiple ones of them, as you can see in the bottom. So in the bottom, it's only the two parts of one new rule. And contrary to the other example where we had commas separating rules, here now, commas separate the different target clauses. And basically, you can say, okay, this example, for example, says, okay, you can become, you can use as user IDs 1002, you can use as primary group 1002, and since nothing else is specified, actually, that rule only authorizes that. And then you have the supplementary group specification. Supplementary groups are introduced by some kind of flag and then GID, saying, okay, you could be part of 1002, but it's not compulsory, it's not an obligation. And same for 48, which is the idle time group. So this required actually some changes in MDO, because now that we can match, so yeah, I forgot to say that also in the from part, which hasn't changed, you can match on UIDs, but you can match on group IDs as well. So the trick here is that when we are in MDO, depending on the request from the operator, I'm going to call set GID. But the problem here is that how the kernel is supposed to know which rule is going to match. If it's a rule that matches on user IDs, then you don't really know at that point. Because what you're going to authorize for this part actually depends on what you're going to call set UID with. So it cannot work. And we have the same problem here, because we call set UID, and what if some program, although it's unusual, but what if some program calls set GID after that, or calls set UID maybe another time? So is this call, or any of these calls, set group, set GID, is this the end actually? Or are we waiting for more calls to happen for the target credentials that we want? Well, we can know actually. So the solution I came up with is to have a new system call that can change all credentials at once. And the benefit of that is that we're able to compare the old and new credentials, and so we are effectively able to match the different rules configured by the administrator. And so setcred actually has even more benefits than that. I mean, it was done in conjunction with MacDo and for MacDo, but it can be used separately if you're already root. It has the benefit that you can change all credentials in one go, and nobody is going to be able to observe transient states where you have the new groups, for example, but not yet the new users. So from a security standpoint, it seems to be a better idea to do things atomically like that. Actually, instead of doing that, we considered another approach, which would be transactions. So we would say, okay, we would call the traditional system calls as we have seen, and at some point we say, okay, we are done, commit the different changes that we have been stacking up. The problem, it's the nice thing about this approach is that you actually keep the old system calls that everybody already knows. That's an advantage, but the problem is that it requires extensive kernel modifications, because most of these calls, they are coded in a way where actually they apply their modifications immediately. And actually, we have some MAC hooks in the different system calls. So you have modules that can see the different calls and say, okay, it's authorized, it's not authorized. And that's kind of a change in interface, because those modules assume you're going to change things now. And now we are saying, okay, we're not going to change things now, let's wait, and at some point we are going to authorize. So really, it didn't blend well with what we already have. And the other thing is that we don't expect actually to have credentials-related calls to change often or to have new ones on a regular basis. So it made sense to actually have another system call that would be kind of encompassing all the different changes that you can do. So mdo has changed, we changed the operation of mdo as well. So that was the old way of doing things. So after, it reduces to, basically, we access the two databases, password and group databases, and we fill the structure saying all the groups and users we want, and we call setcred. And then MacDo is able to actually check the different requests and say whether it's authorized or not. So here are examples of rules. So I know some people have said to me, okay, these rules, they are quite terse. And it's true, actually, these rules are meant to be in a syscontrol knob, where basically you're not supposed to have end-of-line characters or anything like that. So yeah, it's a bit terse, but I hope it's understandable. I mean, for example, the first line above, basically, so you have the from part now, which is before the greater than sign, and the target part is all the different clauses you have on the right of the greater than sign. So basically, the first line says, okay, you can switch to UID 10,002 if you're 10,001. But it doesn't say anything about groups. In this case, that means that you have to keep the current groups that you have. You cannot change them. So if you want to say, okay, I want the user to actually change to group 10,002, it's the second line. But in this case, you have to keep exactly the same supplementary groups. So there is a third line saying, if you want to say, okay, I want to authorize the same groups, but I could actually remove some of them. So that's the third line saying basically, okay, the supplementary groups, they can be the current groups, but maybe not all of them. It's not compulsory. And then you have the line with the exclamation mark, which is basically the same as the second line, which says, okay, you have to keep exactly the same list of supplementary groups, and so on. So maybe, yeah. And for example, for the last line, if you were in group 10,001, you can also enter group 10,002 and keeping your supplementary groups. So you have, it's kind of expressive. There are lots of possibilities with it, which may or may not make depending on your use case. But now it's really flexible, and you can express quite finely which kind of target credentials are authorized or not. And it's a group, so you say UID and GID in the same rule. So it's not possible, for example, to say, to actually change some GID if it's not explicitly specified in the rule for a given UID. But as you can see on the left, lots of rules here would match user 10,001 actually. And as soon as one rule matches, your transition is authorized. So to configure all that, for the rules part, so the MacDo part, which authorizes the transitions, you have a syscontrol, which is security MacDo rules. In fact, MacDo supports jail, so you can have specific configurations for your jails. You have also a jail parameter MacDo rules. Basically, it's the same content as this syscontrol knob. The only thing that is different is that when you're using jail parameters, you can specify that you inherit rules from the jail above you. So in this case, basically, the configuration is kept in sync until you decide that you want a specific configuration for that specific jail. So, okay, so that was for the authorization part, which transitions are allowed. But now, how do we concretely request transitions? So what's actually in the tree for mdo is that you say, okay, I want to become that user. So you have to specify a user. Implicitly, if you don't, it's root, basically. And if you specify a name, we will also set groups according to what's in the different databases. Okay, so far so good. It's kind of simple. You have also the option -I, which is used to say, okay, I would like to preserve my current groups. You don't have to specify it if you pass a numerical ID to the user, because in this case, for numerical IDs, we're not trying to access the database and try to retrieve groups. So basically, using -I, is allowing you to say, to give some username instead of an ID, but just saying, okay, don't touch the groups. And that's basically all you can do with mdo currently. And then you can pass some command with any arguments, so you can launch any command that you want with the new credentials. So that was kind of limited, especially for the groups part. So this is what I've been cooking with one GSOC student in the past month. So it's going to be soon in the tree. Actually, it's under review and should be in 15.0. We have tried to stay backwards compatible, although this was not a big goal because there were not so many options in the initial program. The difference is that you can set or override basically anything. And you can do it, or we have tried to do it in some way that is quite practical for different operators, because we have 3 different modes for groups. Either you start with your current groups, or you start from those in the database, or you don't want any of this, and then we will enforce, that's kind of part of food shooting prevention, we will enforce that you say exactly, you specify exactly all the IDs, just to be sure that there is no, you're not launching something with different credentials than you thought. So that's why the combinations of the different options can be, if you look it entirely, can be relatively complex, but usually for your use cases, that means that the command line is going to be simpler, actually. So here is, so this is in addition to the -u for user and -i to preserve groups that we have seen before. So now we have a bunch of other options. Basically, they are quite straightforward when you see them like that. The only thing is that some interactions, have been designed to avoid food shooting, actually. So if you pass, as I said, as before, if you pass -u with a numerical ID, you need to specify completely all the other groups, unless you say, okay, I would like to keep these other groups with -i. Or you can pass a name, in which case we're going to infer everything from the password database, but then you are able to override. So for the user IDs and primary group IDs, it's kind of simple because override means, okay, forget about what we read in the database and just put something else. But for supplementary groups, it's a bit more subtle because supplementary groups, these form a set. So sometimes you want to keep the groups that are there and just add some of them. So for convenience, we added that possibility. So these are some examples. The first one is straightforward. It means basically just become Alice with the proper user IDs, but all the groups as well. The second line says, okay, you become user 1001, but that means that, okay, you have to specify all the groups because you didn't say, you didn't give a name and you didn't say otherwise. So if you miss something like G or small g or big G, actually, mdo will spit an error saying, okay, some specification is missing. You forgot something. The third line is another example where you are actually, you want to become Bob with the same groups that are specified in the database, but temporarily for this call, you want to be part of the wheel group or operator group, so you can say it quite easily with that special syntax used with -s. And the last example is, it's an example for -k. -k means, okay, I'm starting from the current credentials. So basically, you are going to keep everything except what's explicitly overridden. But in this case, we are not going to check that some things are actually missing because we are just inheriting from your current credentials. So here we're basically saying, okay, we keep everything except the real user ID, I want it to be 1002, and the effective one, I want it to be 1004. So basically, it's very granular. You don't have to specify much things for common use cases. But if you want to be fancy or if you have to specify things very finely, it's now possible. So some of the implementation details. So I'm going to, I'm not going to go through all the slides there. I just wanted to mention the Mac framework. Basically, allows to have custom security policies that are implemented in modules. And the different modules, they work by being called by hooks that are disseminated into the system, and in particular into system calls. In system calls, we often call MAC hooks, and then the models can see what the call is about and can decide, okay, I'm going to authorize this, or I absolutely don't want, or I don't know, I leave it for another module or another check. It also features object and subject labeling. We are not using that actually in MacDo, but that can be quite useful. And it's kind of, it's well described in the manual page. So MacDo relies on that. So I'm going to skip these slides because I'm running a little bit out of time, which explains more or less the different hooks we had to implement and how they work. Okay, this part is maybe less interesting. Yeah, I just wanted maybe to go back to this. So this is one of the control knobs to change the rules. Actually, how it's implemented, we implement a specific function for it, and we tag it with a special flag saying, okay, we support jails actually, and we can have different configurations per jail, but it's just a flag. Then you have to do the implementation. You have to check in which jail you are inside the procedure you declared to handle the knob. So basically, as we have inheritance, we try to we store rules per jail, but sometimes we have jails where there are no rules, and in that case, it means, okay, we are inheriting, so we are going to climb up the jail hierarchy to find the applicable rules. But obviously, if we want to write the new rules for this jail, we're going to write them on the current jail structure. If we did not do that, that would be a security issue, actually. But because that would mean that we would be able to change the rules of some parent jail. So obviously, it's a layer violation. And jail parameters as well, yeah. There is the MacDo, so there is MacDo rules for the rules, but there is also the subnode MacDo, which is special. It's special, but similar to other existing ones, like IP4, IP6. Or basically, you can take 3 values saying, okay, we have new rules, independent, we want to disable the module completely, or we want to inherit. So this has to be, there is some infrastructure to do it relatively easily, so you don't have to recode everything if you need to implement per jail configuration, actually. So to wrap up, so now we can do in FreeBSD, thanks to MacDo, credentials transitions, and control very finely which kind of user IDs and groups are authorized, and that's, so far to my knowledge, there is no credentials changing program that does that. Even Sudo that doesn't do that. You cannot control that finally. There is per jail configuration, which is quite nice because it can be outside configuration, which means you don't have to have configuration files in the jail. You can configure it from the outside. So normally it's well documented. I mean, we spent quite a bit of time working on the manual pages. So maybe then it's maybe not the end. It would be nice to have, I don't know, some handbook section or other articles, but at least for the basis, it's quite well documented. Although the approach that we have presented here is a bit peculiar because we have rules in the kernel, which is kind of, first, I would say, to my knowledge. But, so there is kind of an experimental architecture here, but the implementation and the soundness of the architecture, we consider them really production ready. We've spent a lot of time ensuring that everything works. And more than that, that it makes sense and that you cannot actually circumvent the different rules and the different protections that we have. So the new rules that I've described in MacDo, they are available since 14.3, and the new credentials change requests are going to be available in 15.0. So that is for the current state. And some future work. So we have in progress new knob to actually control which userland programs could benefit from MacDo. For now, I said that's only MDO, but we can imagine that we want to run other credentials changing program without installing them set user ID. Although, unfortunately, for now, the road is still long to be able to actually, for example, execute sudo without set user ID. It's not possible today. There will be lots of stuff to do to actually reach that point, but at least we are progressing towards that. And it's also to be able to support thin jail scenarios where your MDO executable is not necessarily in the usual path. And we'd like to support traditional credentials changing system calls, so that's mostly to support other existing applications, although this is going to be a tough endeavor, actually. Not the implementation itself, but I mean supporting installing some traditional programs without the set user ID bit. Yeah, we're still quite far from that. We would like to log also why transitions are refused exactly. That is a bit complex because we have rules that authorize. So basically, you have to say, okay, all these rules, they didn't match. For which reason? So we have to think a little bit about how we're going to do that. Maybe have also a specific configuration file. Yeah, it may help for the numerical ideas because when you configure the kernel, you have to actually send numerical IDs, not names. At the same time, you can put an initial configuration in syscontrol.conf because you have a syscontrol knob, so actually you have kind of a configuration file for it, except it's not really human-friendly, but it works. For MDO, we'd like to print the final request that we send to the kernel. It's not really for debugging, debugging for the program itself, but for operators, sometimes it could be a good idea because sometimes something doesn't work, and when it doesn't work, we would like to know why. And with the different options that we have and the different rules, it could be confusing at some times. So we like to have that. And I have a new mode also that produces example rules. For example, you say, okay, I would like to type MDO and request that specific transition, and you would like to help the administrator saying, okay, you want to authorize this, here is an example rule that will allow that, for example. That's another helpful evolution. And wish list, so here it's tentative really because we don't, we're not really sure about the direction, but are we going to go towards actually having something equivalent to do as? I think some people would like that actually. So that means maybe prompting for passwords and growing some other functions that these programs already have. So yeah, probably the trick is that it's not that simple. We have not done it yet because it's not that simple in our setting. Because remember, we don't want set user ID executables. So that poses a number of problems. That is to say, for example, for passwords, maybe we cannot read the password database actually. So maybe we'll have some companion program doing that, set user ID, or we do like we did for rules, that is to say, we want to have some passwords in the kernel. So it's not completely clear how to do it. Having the passwords in the kernel has several benefits, contrary to one might think, because we would say, okay, it doesn't really belong to the kernel, but it has a big advantage of avoiding a class of security attacks, which are called confused deputy, where you can actually, with chroot, change a different path that some user program would see. And so you can make some user programs reading configuration files that are not the intended configuration files, for example. Having passwords in the kernel would avoid that. But is it really a good idea? Yeah, we have to think a little bit more about it. And for setcred, maybe at some point the ability to set more process attributes in one go. But that also means that we'll have to evolve a little bit more the existing rules to be able to say, okay, what's actually authorized or not. And we're at the end, almost on the buzzer. I would like to thank also the FreeBSD Foundation for funding this work. And if you have questions or thoughts on the topic, please go ahead. And thank you.
here's a little gift for you. It's a necktie.
Oh, thank
And
you.
Croatia is actually the birthplace of neckties.
Okay,
So, yeah.
thank you very much.
We have time for like one or maybe two quick questions if somebody's got one. Yeah.
Hi. Did you go in, have you looked at how these things are being logged? I'm thinking specifically of like the kernel audit log, for example. Do you know how those records would look like in the audit log, if you can actually tie it to the Mac framework, or if it's just another setcred call?
Yeah, the trick is that the Mac framework, it allows to compose different security modules. So we call setcred, and setcred really doesn't really know about the different policies. There's just a Mac hook in it calling the different modules. So you could log from setcred, you can only log, okay, this transition is refused, but there is no reason attached. We will have to log at the level of the Mac module, actually, to do that. So, and yeah, I would say the main problem here is that we don't expect those transitions to be that frequent in normal time. So this is not a big amount of logging. So it could go in syslog, as we do for lots of things. The only thing is that the problem is that you want to say, if something didn't work, you would like to say why a specific rule didn't apply. And possibly you can have tens of rules like that. So yeah, it's not especially complex, but it could speed easily a lot of information, which is maybe not that useful. So I'm not completely sure. But maybe we have to log all of that for the administrators too. Or maybe they could say, okay, I assume that this transition, it should be authorized by rule number 2, let's say. And then we would output a diagnostic just for rule number 2 saying, okay, it didn't match because of that reason.
Okay, thank you. Anyone else? Yeah.
I just want to make sure I understood right. This is built more for system administrators, or is this something that you would have to include in some sort of a higher level programming language type of interface?
It's really for system administrators, but even for, as I said, for users on a system where you are expected to endorse different roles. And you don't want to just put someone, for example, in a group to access some files. You know that some person is supposed to have different roles. So, and when they're going to have to actually endorse one, then you do some transition and then you go back. And if you change roles, you do another transition. All the stuff we have here, there is a syscontrol part to actually configure it, and then there is mdo, it's a command line tool. There is nothing preventing you from actually calling that from high-level languages, but there is no specific binding for that. Yeah.
If there are no more questions, thank you.
Thank you.
Oh, brilliant. Yeah, so before I start, there's been a lot of man hours going into trying to make this picture show up. Been burning through 5 VGA to HDMI connectors, adapters. None of them seem to understand actual VGA. This is VGA. This is my IBM 486 SLC machine running DOS under OS2. It's all kinds of fun, but clearly not a friend with modern tech. But thanks to all the people who have been sweating like crazy to get this working at all. Should I be behind or in front of the speakers? I'll try this. So, welcome. I am here together with my team from Intersect, previously known as Modern. Some of them are in the audience. I'm not sure if I want to thank them or not, but there you go. I am going to talk about how you can use Nginx and Lua, not on a 486, to protect your 486 if you're doing crazy shit on the internet. Like how you can build a CAPTCHA for your telnet-based BBS, for example, or how you could do rate limiting on your modern TLS server, but before doing any TLS. And much of this you probably don't want to do, but hey. That is an obvious question. Why would one do such a thing? Well, we're using Lua to do real stuff at work. And while I don't really know much Lua, I think it's great fun. Sticking Lua code into your Nginx configuration is both ugly and beautiful at the same time. And also, I'm old enough to be nostalgic about stuff. The internet is a shithole. We all know that. I couldn't find any prior art for precisely this, but you can talk to me in the hallway track for some discussion. Brilliant. There we go. And I can. So if that's not a good enough reason for anything, I don't know what is. This is me. I'm a FreeBSD sysadmin by day. I do payment authentication with my team. We spend a fair amount of time fighting for open source in everything we do, so we're very proud of how we do that. And we're desperately trying to cling to the fun parts of it during these corporate times that we are in. By night, or day, depending what your time zone is, I'm a retrocomputing nerd, like so many of us at this age become. I hoard hardware. That came as a bit of a surprise. I have been called a performance artist. I'm not sure I quite agree with the term, but sure. I'm trying to make old hardware do silly things, especially if it's internet related. And I love spending time on Sierra games, LucasArts, beer, and my trusty Roland MT32. I'm a father of 4 in a less than traditional family. And yes, I have cats. I am partially here to celebrate rediscovery of certain things. Because back in the day, we used to tell computers what to do. That was the beauty of them. They would do what we told them if we could just learn to speak to them. They were not judgmental. They were not limiting our choices by anything but the limitations of the hardware itself. But within those, you could do whatever you wanted. Because now, the computers tell us what we may do. And I don't understand how any young people can learn anything from computers today when they treat us like this. It has become a lot harder to lift the hood of your computer. Try to find out how your iPhone works. Try to find out how your Mac works. It's all really hard, and it's getting harder by the day. And very few people learn anything because they have to. They only learn because they want to. Well, you all know that back in the day you would have to learn stuff to do stuff, so. By way of parallel, my dad and his friends, they collected old cars and fixed them, and old motorcycles and fixed them. They complained about modern cars and other vehicles loudly. Our kids will never understand, I have been told. I did understand at some point. I currently prefer vehicles that are older than me. Sadly, there's not much time to deal with that. But they used to do these things because they had to. They used to own cars that they had to fix themselves because anything else was prohibitively expensive. And they could fix them themselves because they were ridiculously simple in their assembly and construction. Now, me and my friends, we collect and we fix old computers, which is something leading us to complain about modern computers, which you all, some of you at least, heard me do. And my kids are surely never going to understand this, right? I can hope, but against hope, most likely. But we also used to do this because we had to. Most of the people in this room had computers that you assembled them yourself. You had to fix them yourself. Some of you are older than me or got started earlier than I did and had really cool computers to fix. You learn electronics, you learn all sorts of stuff. You reprogram them to do what you want them to do. Which leads us here. A good midlife crisis has the same price tag. It costs the same, whether it involves heels or wheels or eBay deals. But yeah, let's see if we can talk about something I came here for. So this is where I got started with this crazy stuff. It's my BBS that I worked for a year or so to get up and running. It runs on a similarly shitty piece of hardware as this one, back in the office. It runs OS/2. It's connected to a Novell NetWare server because, I need to have my files somewhere. I would like to speak a little bit about the flag on the side there because this is something that is close to my heart. It turns out I was watching the BBS documentary, which you can find on Archive or YouTube or whatever. And one of the things I learned was that some of the very early BBSs in the US became places where people in what became the LGBT community found out they were not alone. And that is absolutely beautiful. And the sysops, they didn't know. This is not what they planned for. It just happened. They created a space where people could meet that didn't even know there were others like them. That has inspired me so much. Now, what's the problem with this, other than, the obvious waste of time? It is a 386 class computer. This is a long time. I think it was in like late 80s or second half of the 80s that it came out originally. It's connected to the internet and it accepts telnet connections. And it's running software that emulates a modem so that the BBS software thinks there's a modem actually ringing when someone connects via telnet. This is all running on the same machine. And also it's running like 3 nodes on the same machine, so it's doing this 3 times over on this 386. And best case, you have someone just running a network scan. They happen to hit port 23. And this machine has to spin up all this stuff. It has to answer the telnet connection. It has to tell the BBS program there's a modem ring. The BBS program has to answer the call and set everything up and start presenting a login screen. And by the time it's done with that, the Nmap scan has passed on to the next network block. And worst case, you have this hitting your network and your machine is doing nothing but answering bogus calls. but don't diss the 386. I know some people like to do that. But to be fair, they can do a lot. I have a 286 that was hit by Hacker News, and it survived 90,000 hits in a few hours, and it didn't skip a beat. I wasn't even around for it. That's very annoying. And the 386 has some interesting features that made it a supercomputer. It had virtualization, the v86 mode. So you can run multiple old-fashioned DOS programs, and they're isolated from each other. It's early hypervisor, right? And virtually limitless virtual memory. Like 4 gigs, come on, who needs more? So thanks to that, it can actually multitask. I didn't say fast, but powerful. But you may not want to try this at home. So this is a snippet of Nginx configuration. I'll try to talk through it briefly. You may ask me questions later if you have. We start by setting up a stream block. We basically say we have a backend server. That is the actual 386. If I'm running 2 BBS nodes, I set it to maximum 2 connections. And I don't want any delays on the TCP stuff, so I'm skipping that. I'm setting up a shared memory block, the Lua shared dict. I misspelled the name. It's users, not losers, anyway. This is in order to keep track of how many users you have logged in at any given time. And of course, 64K is wildly overblown. 64 bytes would have been enough. Then you have the actual server block that listens on the telnet port. It says, OK, we haven't yet passed the challenge. And then we call the pre-read by Lua file, which is an external file with the actual Lua code in it, which I will show you afterwards, which then, in this case, it presents the challenge to the person who's connecting. And then, assuming that passed, we pass the connection on, otherwise we drop it on the floor. So if we passed, then we increase the user counter and continue on our merry way. The Lua code we start by picking up the socket so we can actually talk to it. Then we seed the randomness because I'm told that's a good idea. Then we generate a couple of numbers that we want to use in our challenge, and then we write on the socket basically what is number 1 plus number 2. It's just a simple math challenge for the user. Then we receive, presumably, 1 byte. Now this is where it gets tricky because one really has to implement a full telnet server here, but I don't know how to do that. So if anyone wants to volunteer a Lua telnet server, please go ahead. But for all intents and purposes, at least some, it works. Then we check, is it the correct answer, or do we throw the user away? And of course, exiting with a 403 on a telnet socket is meaningless, but that's what we do for Nginx to do its thing. And what the hell was that? Well, it's Lua doing the magic here. And in the other use case I want to discuss, it might make more sense. Nginx is doing a lot of heavy lifting here. It does the actual network connectivity. It gives me a framework within to run this Lua code. It makes it really easy for me to speak on the network and read data from the network. So I can't imagine doing all this without that wrapper. Might be overkill, but hey, what works? And I suspect it's the first time it's been used for telnet. I would be really happy to be proven wrong. You can use this in anger. I've tried. Or self-defense, which is probably more likely. So let's see. how this works. It's demo time now. Wish me luck. Told you it's powerful, not fast. Where did the mouse go? Yeah, of course, I don't see it because it's slow up there. Okay. Brilliant. I'm connecting to my BBS now. This is a telnet program under OS2. This is the challenge I'm presenting. See if anyone can get the answer or even understand the question. Oh, beautiful, but you're too late. Let's see if I get the answer right. It's 8, isn't it? Oh, local echo is on. Damn. Okay. It's too big for the screen. There, maybe. Yeah, and now I can log in. Yeah, I mean, so that's the CAPTCHA. The CAPTCHA part was done in Nginx. Now this is my 386 back in Oslo talking to us. But I'll kill that one there. Yeah. There we go. So let's see if we can do anything useful with this. This is code that kind of sort of is actually in use in production right now, edited to protect the innocent, etc. So we have a server in Nginx. This is a plain HTTP server listening on a port. We set up a shared memory segment again. Lua shared dict sessions. Then we should actually start at the bottom with the lowermost location block. That's where a browser, for example, would hit with the first, like the first hit on the server. At that point, we invoke the session create Lua script, which I will show you afterwards. What that does is essentially add the just generated cookie into a shared memory zone so we can use it later. It adds a header to ship that cookie back to your browser, and then it sends a 302 redirecting you to the other location block. In this location block, we pick up the cookie that the browser sends us, and then we pass that to the session check Lua script, which I will also show you afterwards. And we also set the cookie again, this time with a much longer lifetime. So in the first one, we set the max age to 60 seconds, because that's how long we bother waiting for anyone. But the second time, you've passed my challenge, so I'll let you have that cookie for a day, for example. And then we pass that request to whichever server we have running, doing whatever it is it's doing. And the Lua code, I mean, this is the actual Lua code running. There isn't more. This is stripped down to bare minimum, but it's enough to get it running. So you start by picking up your remote address in the session create step, the user agent, because we want something that can sort of identify the user. It's also interesting to see in the logs. And we pick up the cookie, which we called C. And assuming we have all those variables, we add the concatenation of these three pieces with just a dummy key value into the shared memory zone. You see I'm picking up the local s equals nginx.shared.sessions. That is the shared memory zone I created. Then you add this key, basically the concatenation of IP and user agent and all that, into this one. And then when the browser comes back, we're in the session check part, where we also pick up the remote address, the user agent, the cookie, and we bring in, again, the shared memory zone, and we check if we can actually find that key in the shared memory zone. Then we let you pass on into the actual service. Otherwise, we redirect you back to the root, for example, or we could send you to space, somewhere else. I don't know. The actual variables I'm using to construct, shall we say, the session information here is, of course, something you pick freely, because maybe you want to allow people to roam between IP addresses but not lose their session. That sort of thing. That's why you have the cookie as well. You can set a cookie and rely only on that if you wish. But it can be nice to pin it down a little bit more. And also, I'm updating the key in the key value store to have a similar lifetime as the cookie, so that you're not challenged every minute. That's the last thing that happens over there. And this actually kind of works. So yes, it does, sort of. It does work to a point. It does have some limitations. You're still going to want to use something like Anubis in certain cases. The thing that an approach like this would remove is blatant scraping of your site. You will still have those initial requests creating a cookie and then hitting you with whatever. But what you can do, which I didn't fit on the screen here, is that once you have the cookie in place and you have started tracking that session, you can also rate limit on a per session basis, where it doesn't matter if it's the same IP address or a different one, etc. If it's the same session, you can rate limit on that without harming anyone else. That is actually quite nice. But you might still need Anubis. But it does actually work very well with any client that supports 302. It's going to be a bit of a problem for those who use, curl and don't specify the correct options. But there's another thing that I mentioned early on that is even more useful. This is a piece of Lua that will, instead of doing this after the client has connected and sent their HTTP request and everything, we do something similar during the TLS client hello. So the client has connected, they have sent the client hello packet to establish a TLS session, but we haven't done any cryptography work yet. We haven't actually done anything but receive the connection. In the client hello, there will be a host name in most cases, which is the host name that the client attempts to connect to. And that can actually be used for rate limiting, if you're clever about it. So this Lua simply looks at the server name, checks with the string match if we have that host name already in our shared memory, and if not, drops it on the floor, otherwise passes you through. And this is useful if you want to avoid cookies, or you just want to save CPU on TLS handshaking, and you stick your session ID in the host name. So when you early on pass the 302 back to the browser to redirect them to a different URL, instead of using a different path, you can use a different host name. You set up a wildcard DNS record that catches everything under whichever domain name you're using, and you generate DNS-compliant session IDs and stick those in the host name and in the HTTP 302 message. which allows you to pick that up before you waste your precious CPU doing TLS. And I'm going back to Anubis now. This is not something I've done, but I suspect it might be possible. What if Anubis, instead of just setting a cookie or whatever it is it's doing, actually does the work of redirecting your client? So you have Anubis running on some powerful cloud service somewhere that has endless amounts of CPU and bandwidth and whatever, and they only pass the request to your server once they pass this challenge. So you can do this in your Nginx, and you're not wasting any CPU. You're barely wasting any bandwidth because the client hello is not very big. And then you can also do something crazy, which I do here, and don't do that, but you can delay the connecting client. The way I'm doing it here with a select call is a horrible idea because it blocks your worker. But let's say you're using the OpenResD package, which is basically all this Lua stuff and a custom version of Nginx. That one has a working sleep call in the Nginx code that you can use instead, and that doesn't block, but it makes the other end think they still have a valid connection. Or you can do some crazy stuff that I was discussing with some people here earlier. How about you have some Lua code that injects the connecting IP into a PF table and make sure that it's dropped in your firewall instead? Just an idea. Or you can send them off to a tar pit somewhere. But end of the story, scrapers must die, and you need to punish them. You need to find a way to, make them pay for what they're doing to us. What is it good for? Probably nothing, but you're still doing TLS unless you pull that latest trick there with the client hello and everything. And that initial connection to actually set up the session can still be expensive. That's why I'm suggesting maybe do that part somewhere else, and you can give the client problem, Anubis or whatever, you can give that to the cloud, but you don't have to give them your data. You don't have to give them your site. You can still host it yourself and credibly say you're doing so. And to me, that's a big deal. What we really need is client-side proof of work during the TLS connection setup, which is actually something that is ongoing at the moment. I was approached after a talk I did a couple of years ago by some people from NLNet, and they've suggested this to the TLS working group. So there is discussion going on how you can make the client provide proof of work before the server has to lift a finger. And that would be fantastic. So that's pretty much the end. The cast and crew is my BBS, and my floppy museum website and IRC server. Join the fun. I think that QR code should work, but I'm not entirely sure. And if you want a copy of this talk, come and get it on a floppy. I think that was it. Yeah. Thank you, everyone. And questions. I have plenty of time for questions, it seems. A lot of people have spent many hours trying to make this work with the video and HDMI and everything. But I'm not saying I won't do it again. This is a threat. Anyone else? Well, you can find me outside as well. Thank you, everyone.
Ja, nein, die haben wir nicht bekommen. Ah. Ich dachte, du meintest diese generische EuroBSDCon 25.
Nein, es gibt eine spezifische.
Yeah, but so what I actually
Eines ist noch ein Terence, der die erst sucht den. Genau, das hatte ich in die Gruppe mit.
You were assuming that VJ would work.
Genau. Und wir schlagen spontan auf.
Ich wollte es halt nicht zu groß, weil es dann wirklich anstrengend war. So, 10 Leute ist so das Maximum, dann können wir nicht mehr zufahren. 30 ist aber
I should have said that also, but it lets you download
Wie gesagt,
both as a floppy image and as a
nee, wie gesagt, wir sind hier bis, ja, keine Ahnung, bis 18 sind wir bestimmt hier beschäftigt.
Also der Laden hat, glaube ich, bis 23 Uhr offen. Muss man halt mal abklären, wie lange die Küche offen wird, aber das können wir dann nachher gucken.
I still have 8 minutes. I can make a lot of floppies in that time.
Bis dann. Ha? Warte mal, Moment.
Wenn es tatsächlich nach
I want one.
Was ist mit
Ja,
Albert?
no, I suck.
Wir können nicht einen Teil mitnehmen.
Wie viel Videoteam seid ihr?
Say what?
Albert,
Yeah, sure. Yeah. So it's bootable.
Okay.
You root straight into the presentation.
Okay.
Or you can also prompt with the IRC clients and also.
wir beiden hier.
So if you fire up the IRC client, it connects to my
Das
program.
Ding ist, es ist ich sag jetzt mal, überproportional überreservieren. Da kommen in Stunden Leute, ist halt die. Was wir natürlich tun können, ist, dass wir halt gucken, was in Phase ist und dann mal einen Stand durchgehen.
Genau.
Ja. Windows.
Eine Stunde von hier weg oder so.
Okay.
Ja, aber ich gedacht, wir brauchen die nicht mehr.
I have one more. No, it's not on.
Ja.
It's on demand.
Ja, nee, dann machen wir das.
If you ask very nice, I'll sign the label for you.
So we actually drove the first 2 days through the city without cards because the bus drivers refused to sell. Ja, wir hatten das wir irgendwie erstmal rausfinden mussten, wo es hier Fahrkarten gibt. Das sind irgendwie schon 2, 3 Tage.
They used it in the other room. Use yours.
Wir haben 2
So yours
Tage
is in my
Urlaub
backpack
vor
over there.
und danach mit reingeschmissen gesagt, wir holen uns so eine 7-Tage-Karte.
Ja.
Das ist im Moment genauso, um herauszufinden, wo die im Verkauf sind, weil die eine Verkaufsstelle halt irgendwie zurzeit geschlossen hat.
Ja.
Und die Zeittickets gibt es nicht bei den anderen regulären.
Ja, okay.
Und dann haben wir eben mehrfach so Busfahrer oder Tramdriver gehabt. Der eine Tramdriver, der so einfach ein bisschen abgezockt hat. Der dann halt irgendwie 80 Cent pro 30 Minuten Ticket bekommen. Aber unsere Busfahrer so, I don't sell tickets, just move in so.
Yes, but why? Because when we get a DDoS attack on our really secure servers, they are throwing 200,000 TLS handshakes a second at us. You know, if I can mitigate that before I do any crypto, I can do 10 million. You know, then it's bandwidth, it's not CPU. And then it becomes a lot more expensive to the other side. No, but that's why this is useful, you know, on a huge scale of stuff. Yeah.
And one moment during the presentation, I was thinking, all right, the Raspberry Pi 4 is 100 times as fast as it uses a tenth of the electricity.
Yeah.
So sometimes there's a reason why hardware is also specifically if you calculate the energy cost.
Yeah, well, it's not energy efficient. You don't get a lot of what's it called? What's that metric for energy efficiency? Yeah, something like that.
We'll probably have a meeting in November of sort of the retro computing club.
Okay.
And I will try to revive that 3 and that I have running Linux 2.0.
Yeah, okay.
That will be fun.
Well, this one also runs NetBSD. NetBSD is not cache, but it's NetBSD 10, which is with 16 megs. It's not fun, but it's still fun because it's. I mean, come on. Okay.
I want to look at the NetBSD.
Yeah, so 386 is not going to work. 486 might actually work because there are some instructions the 486 has that you need. Should I disconnect the LAN?
Yeah. The circuit, as far as I know, was 32-bit Pentium core. This is AMD, GOD.
Yeah, that would work. Yeah. That one probably even has some multimedia extensions, I think. Like SSE and stuff. I'm guessing. So let's see what did I forget. Power.
Make sure you flip it on upward because otherwise it won't pick up your voice.
Yeah, it's directional.
So it's
sorry, your colleague fixed it for me. I don't have a clue what to do with it. Where can I put it on?
there's a clip. I don't know. We are like on the shirt like that. But
Okay.
It needs to be like.
And on off is here.
It's already turned on, and they adjust it on the.
Ah,
board up
okay.
there, so we don't have to do anything.
Okay.
Just someday will come and tell us anything extra to do.
Yeah.
That would be
So, am I live? Loud enough? Great. Oh yeah. Yep. Tune it down a bit. Hello again. Welcome to the penultimate supper talk of today's conference. And I must apologize. I originally planned to bring more technical content than I actually did. Didn't manage to run benchmarks and setups to the extent that I wanted to, but of course I did prepare, and so this is now an overview of possible solutions to the file storage problem, as one might call it. And we will get a short live demo of this garage product that I promised, at least, but no comparison numbers or real benchmarks or so. Sorry about that, so we can keep this nice and short and get an extended coffee break afterwards, or more time for open discussions, because I'm equally interested in real life experience some of you might have had with storage. So let's skip the introduction. Our motivation, what we specialize in developing and what most of our customers run in our hosting environment are so-called three-tier applications. So you have a web front end, you have an application server, for us that's most of the time PHP, and you have a database. But in the case of the platforms that we actually host, most of them Typo 3 or NIAS, people from the US might be more familiar with WordPress and Joomla. Typo 3 is big in Europe. It's an enterprise CMS that integrates with Active Directory, has plugins for everything and the kitchen sink. So people do really, really large enterprise applications on the Typo 3 platform. Was invented in Denmark. And there's a lie in here, or a blatant omission, namely, we have a lot of files. CSS, images, downloadable assets. Siemens hosts a support application that we developed where you can download ISOs, right? For updates of large machines that Siemens sells, like power plants and stuff. So, and where do you put them? We can tackle the high availability problem with databases nowadays. It's not trivial, but we can consider it solved. And some products even go all of the way, go all out and stuff everything into the database. Ever heard of js.wiki or wiki.js? It's a rather modern and rather lean wiki platform, and they stuff everything in the Postgres database. And that works. Nice one. Development is a little bit slow, unfortunately, and we're waiting for the 3.0 release feature-wise for an eternity now. But it's got one of the best user interfaces I've ever seen in a wiki software. It's really slick, so if you want, check it out. But most other applications don't. They store all of these things in the file system. So how do we go about that? In the early 2000s, we were approached by the Typo 3 Association if we could provide hosting for typo3.org. And so we got 4 very high-end machines, hardware rate, ICP Vortex, the good stuff with official FreeBSD support, including the tooling and the management and everything. Now they're bought by Adaptec and out of business. We had 2 web front-end servers and 2 NFS servers for the storage. And only one was active, replication with rsync, and in case one really failed, the plan was to just ring an alarm for the operator on duty and then manually switch it. So, what about NFS? Is there a problem with NFS? Yes, it's networked, sure, but it's not distributed. And there is no synchronization mechanism built in. You need to do that by some other means, and failover is hard. And the reason is that when a client in NFS goes through mount D, and mount D checks if the client is permitted to actually mount the data set or file system in question, he gets back an ID. And you can restart mount D, you can change the etc exports file, you can do everything as long as the client holds that handle with that particular file system ID in it, it has got access. And second, these IDs are not in any way synchronous over servers. So if you were to switch an NFS server, which claims to be stateless, but switch to a completely different machine by the means of CARP or anything, because the NFS server failed, the client will not be able to communicate with that new server because of differing IDs, et cetera, et cetera. So you have to put quite a bit of effort in there to make these things work, even though NFS is supposedly stateless, unless you want to do record locking, et cetera, et cetera, et cetera. So that is commercially available, but I don't know of any ready-made product in the open source sphere that would do high availability for NFS. If you buy a NetApp or EMC squared or potentially TrueNAS, you can of course get that. There's a new thing in NFS version 4 called PNFS. Now we have parallel NFS with multiple backend servers. We can have N storage or data servers. We can mirror data, but we still have only one metadata node. Question to you from me, anyone experience with PNFS? Has anyone ever run that?
Just for testing purposes, the FreeBSD implementation is not really fail-safe. It has a single metadata server, but you can scale out.
Yeah, okay, so the answer is yes, it does scale out horizontally. So if your problem is performance and IOPS, then probably it might be a good solution, but with a single metadata server, we don't really have any redundancy and failover here. After typo3.org, we got the next largest customer of all times. That was Sonnenklar.tv, big German travel agency, now out of business, unfortunately, for reasons. Problems started with Corona, but maybe they had problems before that, and COVID only exposed them, I don't know. They ran their own cable TV channel, and so that meant we had surges of traffic to the website triggered by external events, because just go to the website, book now, right? That one. And so we needed to scale out horizontally, also typo3 based, and we did 4 web front ends with Varnish for caching that worked amazingly well. They were behind hardware, also an appliance running some Linux stuff. Load balancer pair and then high availability configuration. And we had 2 database servers that synchronized. That was the easy part. And for the documents, we just opted to use rsync because it's simple, fast, and robust. And you can run an rsync job easily every 1 or every 2 minutes if you just do the deltas and the data set is not too large. And so we just educated the editors that whenever they upload new content, they need to upload first. Editors were only using 1 of the 4 servers. So they do upload first, then get a coffee, wait for 5 minutes until the replication had taken place, then set the page to online and published, and all the assets were on all the web front ends. Now in Linux land, and we have that currently for a larger customer, there is a tool called lsyncd. Very lean. lsyncd monitors a directory hierarchy for changes, and as soon as there is a change, it fires up an rsync process, configurable, of course, with configurable targets, to bring more nodes into the same state as the source one. And it uses the iNotify interface, and apart from our own FreeBSD hosting and platform, sometimes we get contracts where we manage a larger amount of virtual machines running on Linux, in VMware, in the customer's own data center. So that is this project, and there we use lsyncd for the assets. And on Linux it works. There's a limit to how many of these iNotify handles and files and how deep the hierarchy can be, the Linux kernel can actually handle, but you can tune that, and if lsyncd fails, the error message is actually helpful, and it tells you, yeah, please increase this value by doing echo something something to slash this slash whatever, and that works. And we have a port in FreeBSD that appeared in 2018, and my finding at the time was that it does not really work reliably in any way. And when I inquired with the port maintainer, the answer was, yeah, we had to use lipiNotify, which is a wrapper that emulates the Linux syscall and uses KQ to do that. And I wonder why that doesn't work, or why we never got anything similar to lsyncd, just using KQ.
We have the opportunity to do it. One of the problems is that with KQ, you have to have at least a path descriptor for every file in a directory, so you need far more files to track. With iNotify, if they didn't do that, then it wouldn't work.
Okay, so Jan's argument is that it wouldn't work, but nobody...
If you didn't use KQ correctly. So there's some semantic difference between how iNotify...
Yeah, sure, I'm aware of that. So it wouldn't scale with KQ.
Many files.
Then how does Apple use KQ to implement Spotlight?
They have a whole different mechanism called file system events.
Okay.
You can subscribe to persistent notifications.
Mm-hmm.
Even put the notifications in an SQLite database in case another Mac uses this, so that the other Mac will honor your subscription.
Okay, thanks. So yeah, so Apple's implementation seems to be a different beast altogether, built on FS EventsD, which any Apple user has probably seen once in a while. I do. And the fact that we don't have an lsync-like mechanism is that our KQ has scalability problems because of the number of file descriptors it needs to hold open to watch over a larger number of files. And if we had an iNotify kernel interface, we could do it, but we don't. So then we have GlusterFS. That was originally part of Red Hat and was abandoned in 2023. And at that time, also IX Systems, who had used it in TrueNAS, in the Linux-based TrueNAS scale, dropped it from TrueNAS, so scale didn't really scale out anymore. Anyway, I just found in preparation for this talk that development in GitHub seems to be going on. Latest release was just in July and with a couple of days old commits. So I'm not quite sure about the situation. In fact, for FreeBSD users is our port is grossly out of date and therefore not usable. And for client mounts, you need to use FuseFS, and reports about the reliability of the entire thing, at least at the time when it still ran on FreeBSD and the port was current, are very mixed. So people seem to have lost data and stuff. The nice thing theoretically, if this would work, is that it provides a POSIX file system-based interface. So you can have the actually real file system view. And then, of course, we have Ceph. I mean, Ceph is a 300-pound gorilla here in the room because it's the default, or has been the default, for OpenStack, for Proxmox, and a lot of other products. So if you go to any cloud hosting provider and buy yourself a small VM to run FreeBSD, and if that hypervisor is KVM-based, chances are Ceph will be in the storage backend in the cloud. I mean, OpenStack is still a big thing, and many people run on it. There is no port. There have been various attempts at porting it to FreeBSD. There was a time when it was working and we had a port that was abandoned. I don't know the reasons. It can theoretically be built from source. There are docs even upstream in the Ceph documentation on how to compile on FreeBSD. So if anyone feels adventurous, well, the problematic parts about Ceph is It's a proprietary storage format. It does not play with anything that we have, like ZFS or so we can snapshot. The operation guide says, all right, at best you dedicated raw disks to Ceph, or at least raw partitions, and then we manage all the objects in there. It's a distributed object store that was at first not meant to provide a file system-like interface. The first use in OpenStack was to provide all the images of the virtual disks for the virtual machines. And then people started to put live virtual disks into Ceph and then run databases and transaction loads on that. And we're very disappointed that, oh, by the way, also IOPS in Ceph really sucks. But maybe you cannot expect that from a file system that distributed and that scale out to fare well in this area, and they're just holding it wrong. For our CMS assets, we wouldn't have a problem with IOPS as long as read operations are fast enough. But operation of Ceph is also quite picky. I got one remark during our BeehiveCon 2 days ago. I should go ask the Proxmox support about how to replace a failed node. That seems to be still very difficult and error-prone thing when you run Ceph. So good luck. So the problem seems to revolve a bit around the fact that we expect to have a POSIX, or at least mainly POSIX-compatible file system interface. So we could just have directories, and we could open, read, write, and close files. Maybe we can abandon all this stuff. There's also MooseFS, which I didn't have time to look into. Anyone ever used that? Seems to be quite a big commercial project. They have a GPL open source part on GitHub, and they also sell a pro product with more features. Don't know. Then we have Seaweed, and now we're getting a bit to the heart of where this is leading. Seaweed, instead of a file system, provides an S3 compatible object store. And maybe for web applications that just need to retrieve assets and save assets, doing away with the file system metaphor is a way better approach than using a file system for that. Also a comment during EuroBSDCon, yeah, I don't know if it's our port or if it's upstream, still some bugs that might lead to failure of operation and data loss, so a little bit more work to do. And then, I mean, everyone who's been in the business for a bit longer, like I was, for a while, you could read blog post after blog post about Linux and DRDB. So we can replicate a disk partition with JumGate and with hasty. So, but how do we do the replication? We put a Jump mirror on top of that, or use ZFS. But then we have replicated data, so we have the same data on 2 hosts, which is great. But how do we serve that out? So it's NFS or whatever you put on top of it. So this is also leading nowhere, and definitely not fun. So, and this leads to this tool that I found a couple of months ago, and then 4 weeks ago or so, twice a year we have a special day in our company called the Just Do It Day, where everybody on paid time gets to work on whatever they want, as long as it has not anything to do with daily operations and customers and anything. So I worked on Garage at that day, and it's again an S3 compatible object store developed by a French company. I had hoped that maybe someone would be present on this conference. So, no? They claim to use it in production for years. They have a big website and documentation and everything. They claim that all of that runs on, on Garage. I don't know, and the company website itself is a bit secretive. They don't tell how many customers they have or how big their data center is or whatever. I had a similar meeting at EuroBSDCon in Paris, I guess it started. There was another French company who claimed they were running a data center full of jails, and they had jail management software, and they would open source it really soon. And then 1 or 2 years, I had the patience to ask again, every couple of months, and then it just finished sometime. So I cannot say anything about them, but the software exists. We have a current supported first-tier FreeBSD port. It's really easy to deploy. Documentation is quite good, not perfect, because you have to look up things for your first deployment in different parts and in different branches of the hierarchical document. But it is complete enough and precise enough to get this thing up and running. It uses a regular file system for object store and does its own replication and checksumming across nodes. The documentation says you can put the data on any file system because they will detect errors and repair. They support multiple local stores. I don't know quite for which reason, because I would manage the storage locally with ZFS and then just give them a top-level directory and be done. But they say you can have multiple hard disks, and they will also locally make sure that data is saved in a redundant fashion across these hard disks and everything, so they can do that. And for their metadata store, they recommend a file system that is in some way fail-safe and has checksums, so the local node doesn't fail because of file system errors, but they also, of course, replicate the metadata across all the nodes horizontally. So with eventual consistency, not immediately or synchronously, but with eventual consistency, all nodes will be the same. When I stop writing a couple of seconds later, all nodes will have the current metadata. And they are aware of regions and racks and servers, so you can configure topologies and hierarchies and can say, okay, this data is so important, I want at least 3 copies in Falkenstein, I want at least 3 copies in Helsinki, I want at least 3 copies in Amsterdam, and then the software will manage that. You can, of course, also just use it locally in one data center and say, okay, please spread this across these 3 servers. 3 nodes is the minimum that makes sense, because servers might disagree and you will have to need to break the tie. So 2 is one to few. Okay, and then for a quick demo. I have spun up 3 FreeBSD VMs in VMware. Let's see if they were put to sleep or if 1638, no date and everything is okay. Yeah. This is the package. When I installed it, it was on their current release. As I said, it's AGPL license, so that is not a problem for operators like us. The AGPL is the anti-cloud provider license, so I cannot run Garage as a service, but I can install it with the jails that I present my customers, and then the customer runs it. I may also help configure it and everything. That's not a problem with AGPL. So, and all goes through a single binary command line interface. So let's say Garage status, and there we see we have 3 nodes. I pretended they were in 3 different zones. So although they are all on this machine, so I have at least 3 different zones, so everything is green. Algorithm is happy, and you can also look at the nodes. Let me see. Node ID. Right. This is the node ID I'm currently working on, and so these are the credentials that you need to join another node to that. So this is all very, very easy and can all be done with a few commands that are also quite well documented, and you can join additional nodes. And when you reboot the entire cluster, the nodes will find themselves via multicast on the network. And in initial finding, if you have a dedicated storage network, then they will just find each other. The config file looks like this. So main things, you have a metadata and a separate data directory, which are visible in the normal Unix file system, so you can put under that whatever you like. ZFS would be my preferred solution, of course. It does regular snapshots of the metadata, and then you have a couple of network settings, like where is the RPC to be found for the synchronization, where is the S3 API to be bound, and the S3 API, in addition to the storage bucket stuff, also contains an HTTP endpoint. And I think it's really nice that Garage implements that. MinIO doesn't, but you can use any service that implements the full S3 feature set as a static web server. So that's the next thing I'm going to do at home. I have this 7-node Turing Pi, Raspberry Pi compute module cluster, tiny thing with 7 computers in it. And I was always looking for a clustered workload that would run on FreeBSD, so that's the next thing. Build a static web server on that with Garage. Now, how to access it? You need an S3 capable client. Yep. And then you can access the bucket that I defined and put files to it or read files from it, and to show also the HTTP interface. So that's it. I uploaded via S3, via CyberDuck, these 2 files, and then I can access them in the browser. And storage for assets, simple as that. And I found that really nice and encouraging to dig deeper into it, and I think we will evaluate it in projects. I did a bit of a torture test by the means of S3 benchmarks, and I couldn't break it locally, but of course I cannot yet say how this will behave in production and in the long term. So that's what I prepared. I hope some of it was instructive for you, and you're not disappointed that I didn't make to prepare more. Maybe next year complete Garage only talk. If it's great, I would love to do that. So see you all next year, and thank you very much. Yep.
How hard is it to add servers to the cluster at one time?
I can repeat it.
Okay, but that's why we have this. How hard is it to add, or even worse, remove nodes from the storage cluster?
Simple command. Simple Garage node something management command. The one thing is that all servers that are in all servers. Oh man, what do I want to say? They recommend to have a private network for communication, and even across regions have some sort of VXLAN or VPN, so there's a private network for all of that. And then you just add a server to the cluster, or it's with a single command, and removal is the same. And of course, and now this is the high availability part here, any client can contact any of the servers with the valid endpoint on any of the IP addresses that any of the servers has. So no matter which server you contact, once the consistency is achieved, because the metadata has been replicated, it doesn't matter, and you have the full view of all the assets. And then we can, of course, do things like use CARP or Heartbeat or HAST to switch the single configured IP address that the client systems use, the CMS in our case, to switch this from server to server in case a server fails or the daemon goes down.
Hi, So just a remark regarding the owners of the garage code. The Fleur is not a company; is a non-profit organization, and they use old hardware they store in their own home, and members of the group host things on the recycled computers. And as a non-member, you can access the services. It's something like 15 euros per month or something like that. I don't remember exactly, but yes. So don't expect too much support. I think is also, and most of the communication they does is around. Associative cafes and places. So yeah, so that explains maybe.
That explains why I didn't find big company webpage and a list of customers, etc., etc. Of course.
Yes. By the way, if you need any help to reach them or talk with them, we can help you in French.
Yeah. Je parle pas français. Just enough to know this sentence. Oh, all right, I find my way around Paris and I can order at a restaurant and stuff, but no conversation, unfortunately. Yeah, that's nice. Thank you very much.
I was curious about what do you use for distribution block storage, or if you use Garage for it, or do you think it's not important?
I think it's interesting for us to use it as a storage backend for CMS-based applications. Exactly.
Okay. All right.
Just a comment. I remember Stefano dismissing Garage in favor of SeaweedFS for some reason. I don't know if he benchmarked or did like testing or something, but because I asked him, especially because we were interested in Garage as well, and I think Dave is running SeaweedFS in production somehow-ish. I don't know about the bugs that were mentioned.
Okay.
Where it like...
Yeah, thanks for mentioning it. I would love to talk about this. Is Stefano still around? Or? Let's see. Yep. But then maybe he was the one who also said on BeehiveCon that SeaweedFS needs some more work, and maybe he's just referring to the FreeBSD port. I don't know. Okay, that's it. Okay.
Andreas and I are presenting our work that we have been doing since roughly March of last year. When Andreas talked to me, hey, I need to do a master thesis, do you have any ideas? I said, yes, I have something in the back of my mind that I always wanted to do but didn't have enough time, and that is pretty much the result. So let's get started.
Let's get started. My name is Andreas Kirchner, this is Benedikt Reuschling. We are both lecturer on the Hochschule of Applied Sciences in Darmstadt, and for the last 5 years we are confronted with AI abuse in our university staff. So it's really hard to find out which solution is from the students and which solution is from AI. And that comes to the point that we have developed this system that we are showing you today. Yes. First of all, thank you for the invitation that we come here to Zagreb, and then we can show you our tool that we developed in Darmstadt. And yes, now Benedikt will
show you the agenda, what we're planning to do. So first of all, when you have a crazy idea that I have, I'm not sure if it's actually working. See what AI can come up with, and this is the picture it spit out. So I basically have a couple of daemons there. I have a bunch of Linux penguins, and so it turns out as if you enter chaos education as a rough term, then you get weird pictures. I'm not sure what the Death Star in the upper right corner is doing there, but yeah, that's what AI gives you these days. And let's see what we're actually talking about today. So first we have a background, like why did I came up with this, what was the idea behind it, and what came out of it. Then Andreas started with me doing some brainstorming how we could implement this. So that's a basic structure of the program or the system we designed. Then the actual system concept. If you're working in academia, they will always want to have this, especially when the student is writing a bachelor or master thesis about it. The structure needs to be there to have a bit of, science behind it. Then we have the evaluation system. So the evaluation system deals with the users of the system that are later playing with it, if you want to call it that. And then following up with Andreas giving you a deep dive into the code a little bit, how it works and what we used and reused. Then also the feedback for the system that the students in this case, students are kind of good guinea pigs because they kind of need the grade, but you cannot pay them money, but they're willing to do things to get ahead. And then followed by the live demonstration, which is always interesting because systems can crash and burn unexpectedly. And then at the end, hopefully we have a bit more time at the end for questions. All right, background. So what is this all about? So as many of you know, I teach a course since 2012. Oh great, I feel old already. In the Department of Computer Science where I studied. I'm not a professor, I don't play one on the internet, but they give me students to teach in my Unix class, Unix for Developers. And over the years I discovered or saw that students are actually not bringing as much Unix knowledge as I hoped they would bring. And we're also trying to teach them more system administrative skills so that later when they graduate can work in a company and do system administrative-like tasks. And it's still concepts because academia is mostly basing their teaching on where is it in a textbook and what kind of concepts are behind it, but not the actual practical work on the system, on the console. And I thought it would be interesting to enhance it a little bit more and add some gamification elements to it. And that was the rough idea that we started with. And in recent years, the last couple of years, the last 2 years, especially when the AI things came up, students get an assignment, they have no clue how to solve it, they put that into AI and something comes out. Not always a right solution, but some students are desperate enough to use that one. And so we thought, let's see if we can give students an environment that they can work in with even with sysadministrative privileges, aka root, and still figure out if they are better with AI or not. And that's the rough idea I had.
So that's come to the objective of the project. We will try to develop a system whose learning concept is based on principles of chaos engineering, because chaos engineering has shown that the last 5-10 years for Netflix that is improving the skills for problem solution and problem solving. Then the restriction of the AI abuse should be implemented, that we are able to measure the performance of the students in each
course.
Each course, and increasing, of course, the intrinsic motivation not to cheat if during the using of gamification. So you see a high score list, and then you must be good to climb in the levels, and then you're motivated to do that to show your other students how good you are. So basics and the state of the art. We are using, as I said, the chaos engineering principles. It's a concept based on Netflix. It's like a monkey running through a server center and putting out new cables. And then you try how long will the system last and how long can the system be online with it crashing down. So you can improve your system that you can put out many cables and it work down to still working out. And yes, and the result is the problem-solving skills of the Netflix employees are really good, and the downtime of Netflix is really low.
So what are we, of course, when you're writing a thesis, once again, students need to do some prior work research, what has been done before by others. So we found two things. The first one kind of sounds scary. If you type that into Google, maybe law enforcement knocks on your door. The bomb lab. So what they do, basically, they give students a binary and they need to disassemble that. And of course, the first time you're doing it, you're just executing it, boom, and a hit counter increases for that student for this binary, and it's slowly GDB or maybe strings to read between the lines and find little nuggets that the instructor put there to understand more and more how to use GDB and debugging programs. And each time you make a mistake, it goes up, and the binary only like up to 5 times, and then it's not completely, or it's completely gone. So that's also a challenge for the students to not accidentally application blow up, but also how you can understand more about the binaries. The other one is set servers. Some of you may have known this. So this is where you can play certain scenarios. It's an AWS box that you get access to. A problem in there where, I don't know, a web server is down or the database cannot accept writes anymore, and you need to fix that. And when you think you have fixed it in the live system with administrative privileges and all, then you need to click a button and say, have I solved this? And then the system in the background will check it and give you points how quickly you've done this. And so I thought this would be interesting to mix both concepts together into a special system. So why don't we give students a jail that they can work and play with and even have root access without making too much damage? And we as educators, or I, will inject an error into this jail, and then problems pop up. And the students have to first find and solve the problem, and also be quick about it, because the other students are against them. And who's the fastest, who solved that, will get a higher rank. And so I thought, what needs to be in the system to be useful? First of all, for me as an educator, I don't want to deal with a number of big, config files to construct such a scenario. I want to have it much easier to create such a scenario, because then I could also give the professors or to other lecturers and say, hey, can you use this for maybe networking or other scenarios? And that way it's not just tied to my own lecture. And it should be really easy to run this in a lab environment or as a conference, for example, like this one maybe. And they should also have like a high score table to have a little bit of competition, because some students are better in some tasks and others are better in others. So after you play 2 or 3 such scenarios, you get higher ranks on the high score list. And it's also afterwards the idea to, okay, scenario, let's all get together and discuss what the solutions are, because there's typically more than one solution to a problem, and that way everyone learns from each other. Hey, you solved it this way? I haven't thought about that. I used this other tool. So that's the idea, to actually share some knowledge about possible solutions. I'm also okay with students giving them root access in their own jail. Of course, the network is knocked or is limited so that they don't do too much damage, but they can also install their favorite tools if that helps. And The solutions really vary, and I can watch the students doing that because I can always look inside the jail, but the students cannot, look into other jails. And it should also be easy for students to get feedback on their process. So when they have solved such a scenario, they get a little message on their display, congratulations, you solved the scenario, and the high score list is available to all the students during the exercise, and they can see, oh, team 1 has already solved it, oh, and team B is right behind them. And that is the idea I had for this part of the system. Technical requirements, it should be open source, other people should be able to take it and modify it to their needs, add own scenarios to it, and it should have components that are easy to put together.
Our solution should be open source, so we use FreeBSD 14.2. Jails provide excellent isolation for the student systems, that the students can do everything on their own sandbox and try things out to not harm the host system. Then we use Bastille for jail management, and it's Docker-like with config files. You can describe how your jail should look like, and then you can run it easily. Cron jobs check our jails and update the high score lists. So every result the students make will be counted by a cron job in the old version. I'll come later to that. And we use OpenZFS, provides quick jail snapshots and rollbacks, as we heard yesterday in the first talk. And low cost and customizable, stable, reliable, and scalable. So for university stuff, it's important that it's low cost and that costs not so much money for the students. Yes. And we use custom shell scripts for deployment and management. We are powerful networking tools. We're using PF with NUT rules. So we have nutting based networks that you can, from the outside, you can jump inside the jail over the controller system. It's the host, and the jail is hosted. Then we use run commands from outside of the jail. So Benedict can run every bad command into the jails and can disturb the students. And yes, that's this side. Our first concept we are built in the lunch break, I think, was this. So you have a student jail, or you have one-to-end student jails. You have a controller system, a monitoring jail with Grafana and Prometheus, and a web server jail. The web server jail only hosts the high score lists. The controller system is based the host, is native on FreeBSD, and hosts the monitoring jail, the web server jail, and the student jail. And the controller asks the student jails if you have successfully find a solution for this scenario, and the student jail say yes or no. And the students can jump over the controller system via nutting into the student jail. And the lecturer can control the whole system with an easy build-based menu. So, first of all, it's important to find a structure for the evaluation system, because every solution in university stuff is mostly not measurable, because it's independent on how students write their words. So we find a solution. If in there we try to break down the whole complex answers in 3 difficult scores. That if you be good and keep more points, and if you are weak, you get lower points, and to not punish bad students, we are built in a ranking system. So even if you are not so good, but if you are in the limits of the university, you can pass this course. That comes to our evaluation concept of easy. Easy is built on our whole time of a university hour. It's 45 minutes, I think, and 1/4 of that is 11 minutes. Then we have our medium scenario. It's one you customize one config file that we'll show you later, and the process time is 22 minutes, or the double of the first scenario. And big surprise, the hard scenario is 1 hour, and also the double of this medium scenario, and we have 45 minutes. And the multiple config file must be changed to pass the scenario, and yes. Then for the point distribution, we use this point distribution to not punish the students so hard. So if you are good and you are the expected time of the professor determined for this task, you get half of the points. It's like the same whole published systems in the world. you get half of the points. And if you are good, we want to find a way to make difference between super good students and not so good, or good students. So we built in a bonus system. If you are good in the time of 10%, 50% lower than we are expected, you get 10% extra points. And if you're on a 25% faster than we expected, you get 5% extra points. And then we tested it, and it worked very well. Our point distribution is built on these pillars. We have linear distribution points, as I showed. We have bonus point program to motivate solve properly, quickly, and efficiently. And of course, we have a multivariate combination of the time efficiency and level of difficulty to make a whole transparent evaluation level and process. And also use the anchoring effect, promote the feeling and high progress and performance. So we use 1,000 points as basics, because if you get more points or higher point level, you are excited, I'm good, I'm not that. If you get 1 point for a good solution, you're like, okay, what should I say about this? So yes, then we use a fair distribution, rewards efficient work without discourage or punishing to get a good acceptance on our students in the university field.
All right, so here we also had a chance to play it with students in the lab group of my class. And of course, in the class itself, I taught some of these concepts that they would probably have to deal with without knowing yet. And that's how we saw that some students were actually quite easy with the solutions and some others were more struggling. But based on the time it took and whether they solved it or not, they get their point scale. And you can kind of see how much this is and who the winners are. And if you would play an additional scenario, then it could have been that the top one would fall down because another group was faster in solving that particular scenario. And over like the course of a typical semester, if you play this, we would have this natural competition between students trying to win the top prize or the top place.
Let's come to a deep dive. How that system work. I will show it later in the code. First of all, we create a student system, or we get a cluster of student systems with jails. Then we apply a Bastille template on the jails, so we can configure a base system with basic items like Vim or something else we need for the system. Then we're using controller credentials via SSH access via keys. So we have passwordless authentication implemented. And snapshots for creation, because if students make a horrible mistake, so they don't get, must continue their work where they're stopped. So we can roll back the whole system until this the 1 hour, I think. 1 hour backups we're creating in a distance of 1 hour. So if students come after 30 minutes, I have to did a mistake, we can roll back. And of course, we are implementing a logging system, so Benedict can sit at home and can look on the logging system if a big error has happened.
That was definitely helpful during development.
Yes. So our creation script, it's a bit hard to do that here. I try it.
That's some pointing thing.
The creation of a jail is with Bastille works like so. You create group name, you have a bootstrap version and a subnet we defined with nothing rules. Then all is written in bash. Then we are applying our template like here. After that, we are using our root controller password that Benedict can jump into the hosts, into the jails, and then we copy our SSH credentials on it. And the last part is the snapshot creation and the logging system. So, and the Bastille template look like this. It's a basic display template for our controller. On the controller, it's the host. It's based on the monitoring for Prometheus and Grafana. We have our service Grafana started, make a redirect of TCP ports, then we can access the system from the outside, and we install at first important packages on our jails. And this is a screenshot of our test labs where we started with students, and this is the performance system with Grafana. So you can see it's really a low performance, high performance. You don't need so much resources, and yes. So a scenario is built on typical four components: a task description where the professor write down how the task look like, a scenario template where the failure is implemented, and a solution script where we test if the failure is find a solution for the failure, and difficulty degree, as I said in the slides before, 1, 2, 3. And of course, additional files. You can add so much additional files you want. You can add a whole Apache server, a whole Apache logging tree, and yes. And the typical scenario sequence look like this. The lecturer select the scenario, then the create observer cron will be created. The determine the time before the scenario will be made, that we can exclude the time before the scenario was started from the system. And the student solves the scenario. After that, we calculate the points. The scenario will be exited, and the communication between the students will be happened, so they can talk about their solutions and how can figure out which solution is the better one. That was really important for Benedict.
Yeah, because I also need to know, what if individual students are struggling, or if the end discussion is important, so that everyone gets, even if they didn't pass the scenario, that they get a couple of ideas from the other students.
And after a scenario is finished, you can roll back with our snapshot system, or you can run with the individual configured jails to next scenario.
Yeah. For example, a student during the scenario could crash their machine or delete important files, and we have now a way that we can individually restore that particular jail without having to stop the scenario for everyone.
Yes.
So why don't we play through this, right?
Yes.
So Andreas will demo this, and I will explain a couple of extra things. So imagine, like I told before, this is not only in a student scenario, this could be in a company training for your sysadmins, or you maybe have had a recent, I don't know, attack or something, and you want to replay how you solve that. This system could also do that. So we're just waiting for image to come back.
Perfect.
Computer went to sleep. Here we go. Here we go.
No.
We're back? Okay. And so we need to switch the pictures.
But it doesn't work with that.
Oh, it doesn't do this? Oh, here we go.
Now.
All right. So at the beginning, the class hasn't started yet. I need to set up the initial system and go about my configuration. This is the main menu that we created. It's all, expensive graphics were used. We spared no expense. And first of all, we need to initialize the system. Typically, I would do this in my own office, not live in front of the students, but this takes a couple of minutes to download packages and sets things up. And so let's do that. Here it comes. And so what students are then getting a login credential so that they can jump into their individual systems. I hand out these logins to students. Of course, they all get different logins so that they don't, jump into other systems and look around or cause mayhem there. That's my job. It's actually quite mischievous to think about scenarios. And how could I mess up the systems, like remove execute bits or delete binaries or make other kinds of bad things? Oh, look, here's me again during the login. So after the initialization is done, now I can start a student scenario. I have created 3 from each category. But it's easy to add another scenario by just editing a Bastille file, and that Bastille file basically executes the mischief that you want to do. So why don't we do a DNS, right? That sounds like a beginner thing. It's a nice combination of system administrative parts and a bit of networking in there. So this is what the students will see on their jails. We have also the view for the jail. So this is what the students will see after they've logged in and poked around a little bit in the system. Occurred on your system, and for some reason we have no way of installing packages anymore for some reason. So why don't you try to fix this and correct the problem? And so Andreas would go and poke around and see, what can I do? It's supposed to be something about the network, or maybe I try to update my packages. It said something here about my packages not working. You probably need to be root for that. That's also a part of the learning, like who can do what. So again, the students can work with the root account in that jail. And let's see, and they're like, this is unusual. I cannot update packages for some reason. It's not package-based, it's some problem with networking. And then the students hopefully remember, we talked about networking and what's necessary to communicate with hosts. Let's figure out if we can make a ping maybe? And during this scenario, I, as the teacher, can always send the student a broadcast message, either to nag them, haven't you solved it yet? Or give a little tip if students are just struggling and have no clue what this is about. So I can send them a little message like, have you checked your DNS configuration recently? Maybe it's there. So I could really be nasty and send them all kinds of nagging messages. Or I have a nice day and give hints. So let's switch back to the student system, and that's what they then receive on wherever system they are. They get this nice little message, and maybe then we have them thinking more about a certain scenario. So Andreas is now thinking, DNS, there's some file called etcresolve.conf. I should check that. Maybe there's something in there that I need to fix, or maybe is not right. And install their favorite editor if they like. They have root access, but they cannot install packages. So they have to use what's there. If I'm really nasty, they only have ed available. But here you figure, that name server over there, that's not really working. So we should probably change that to one that works. And saving and exiting, that's always a challenge for the Vim users, for the new users at least. And now we try package upgrade again. Maybe that's solved now. And in the background, the system is already checking whether the student has solved that assignment, because I, as the scenario editor, also defined the conditions that the system should check and what the winning scenario is and what kind of, here the message, you have successfully passed this scenario. And now, if I look at my high score list, that particular user or that particular team should have gotten points based on the time it took and the difficulty of that particular scenario. So, okay, that's solved, all right. So now, this is of course not a single team, but maybe a class of 16 students, each individual jails, and that seems to be solved. I typically wait a little bit, but I can also nag them a little bit. Hey, a team has already solved it. And okay, now that this is done, I can stop the scenario and either let the systems remain as they are, or restart the system and refresh it. And I think I would like to end the scenario now. I guess most students have solved it by now, or should have. And now here's the question whether I want to reset all the systems. Whatever they've done in there will be thrown away, and they start with a fresh system, or they continue with what they have. So we probably don't want that. Or let's reset everything. And now ZFS goes and rolls back jail file systems and does all its magic. And it's done in an instant, so I can play multiple scenarios in a typical lab group. And point 6 is if a student has somehow managed to destroy their system spectacularly, I can reset only that particular system while the other students can still play. What else can we show? We can, basically stop the scenario in the status, or that it's currently in, or we show what kind of systems do we actually have, like how many are still present in the system, and IP addresses and stuff. So that's good for debugging purposes if something went wrong. Are they supposed to see those IP addresses? Okay. No, that's okay. So and I can always, while the scenario is playing, maybe the students need a couple minutes to think about this, I can already look at Grafana templates or Grafana output and see what the dashboards are showing. Is the load of the whole system too much, or is someone attacking other systems, for example, because they have root access, and fix their networking, by the way. So that's also for me possible. If someone is misbehaving, I can still have control over the jails. All right, let's see what else we have as slides.
I hope it will work now. Yes.
Yeah, here we go. And the more people I talk to about this, they have all kinds of good ideas after a couple of minutes, what kind of mischief you could cause, and let other people, deal with that. And of course, these could be real scenarios. Something is broken, the web server is down, the database is crashing, all kinds of things we all probably have experienced. And so overall, we did that with 2 lab groups of students. One group was allowed to use AI tools in addition to internet and stuff, and the others weren't. And we wanted to figure out if AI tools were helping them or not. And it turned out that if students weren't able to formulate the problem because they haven't analyzed it properly enough, the AI just went all over the place and tried different things, but that didn't help at all because the problem wasn't properly defined. And so it's still students have critical problem-solving skills, also while playing realistical scenarios that are used in the industry. And the feedback we got, they had to fill out a little questionnaire at the end. Many wished for more scenarios like this because typical lab groups are standardized and every student get the same assignment, and after you've seen the first couple of them, there's nothing new, and of course they get copied around. But if each scenario is a little bit different and they don't know what they will get to see, they don't expect much, then it's original, and the gamification aspects with the high score list makes it a bit more interesting to see, are you really a good student that can make it or can solve it faster than other students. We're also a bit worried whether the SSH access would break or if the network would be overloaded with connections, but luckily that didn't happen. Maybe it's the university network. And also the scenarios loaded correctly. Again, by that time we played that with students that was still in, let's say, beta stadium or beta status. And luckily Andreas was able to be in the lab group for any emergency last-minute shell script changes. And so I could focus on the actual teaching and presenting the scenarios. We also had students suggesting stuff for the web interface. For example, one student was like, what scenarios, but when I look at the high score list, I don't see which points I get for each individual scenario. And that student suggested maybe there's a little drop-down button that would show individual point scores for each scenario. And that's what we can probably do in the next iteration of that tool.
Yes, and for me it was really important that the user friendliness is good, that the system has good acceptance in the system, because our students are really lazy today and they don't want a system who is hard to learn. That was the clear navigation menu for them, important for me, so they can jump out into with one line of code. It's really easy. Then infrastructure as code, so then they can drop it, deploy it on an OpenStack cluster, on our HDR cluster, or something else. And suggestion for improvement visual web interface for students. So yes. And of course, it was important for me to find out if the scenario difficulty degree is a good, it's good selected. So I did one of P difficult value analyze. So you can find out if too many students find a solution for a problem in a too fast time, the difficulty degree is too weak, and if too less students find out a solution, it's too hard. And this was the result of that. The first one, shell change and the DNS manipulation, was okay, and the log rotation was too difficult. So maybe Benedict can explain what log rotation was.
Yeah, so log rotation basically deals with, we put a big file into each jail, which is basically using up all the disk space in there. And if you've been in that scenario, everything is quite sluggish and you get all kinds of messages. Yeah, the disk space is low. And students had to figure out, okay, well, if I delete that big file, well, that's not actually good because it's appearing again because the log file is still growing. And so they also have to learn on their own, like, what is log rotation and what kind of settings do I need to do and how do I restart the logging daemon. And all these things I didn't explain to them, but this is the more scenario that is difficult, where they have to do a bit more research. And so that way I also understood much more directly the stuff that I taught in the lecture, whether they already internalized that and had already the knowledge to apply this on a system rather than waiting for the exam, and by that time it's already over, right? And then I find out that they didn't learn much, but that's then the end of the class or the semester.
So, and outlook for the future development is expand the variety of scenarios. So Benny and I will develop much more than scenarios for the system. And of course, currently we have the cron job solution. So we are limited on 60 seconds limitation with the checking algorithms. And that's a problem because if you are at the first minute first second of a minute, you must wait until 59 seconds until you get your answer from the system, and it's really, really annoying. And then the high score list, more transparency, as Benedict said in the feedback, the students would be able to look how much points they get for each scenario, and check the transferability of other courses like network technologies or IT security in our university. And that's come to the point that we improved our design. So we are now able to clustering student jails, 10 student jails against 10 student jails, and if each student jail cluster have one controller, and Benedict only controls now the controller jails, and these rolling out scenarios on the student jails, and you are now able to run 2 different scenarios at the same time. And of course, we changed our SSH connection to HTTPS, pull and reply requests, so we're now much faster than before, and the performance is better. Yes, and the scenarios are now stored in the database. And everything else is the same, but currently we are only finished in production ready with the Chaos client. It's written in C, and every web stack and web interface is self-written, so it was really hard to do that in that performance case.
And the scenario database also gives me a chance to kind of have a big selection. What do I do this semester? And I don't need to think of new scenarios the more I have. I could also think about putting that on GitHub or some other public place, and others provide scenarios similar, because it's really just editing a Bastille file. Okay, do you have any kind of questions about the system we presented or the demo we did? Yes, Brad. Do we have a microphone over here? Let's see if that works. Okay, then talk into my neck.
So how do you know when a scenario is completed? It looked like it prompted right away and said that it was successful once you run package and it worked.
So Andreas implemented also the solution to the scenario. So there is a checker script behind that. For that particular scenario, it checks whether, in this example, etc resolve.conf has a value of not 000. So you, as the scenario creator, also needs to define the conditions. Is this file there? Have the execute bits been restored? And all kinds of things you can think of. That's what you have to do as scenario creator. And the system just checks these conditions.
Cool.
Yep.
That's awesome.
Yeah. Again, like we had on one of the slides, think about a group like this. You probably can solve some things easier than the students who are still learning. But you could do this at a hackathon or as a company event where you say, okay, let's get together in the afternoon and play a couple of scenarios, and at the end someone gets a little bit of a trophy, who is the best system administrator.
Any other questions?
Neck talking again? Well, I can give this also to you.
I was interested if you are also collecting the TypeScript or similar in order to understand what, or like shell history, in order to understand what the students type and maybe to understand what kind of error they do or mistakes.
We don't do that currently. So what we could, I mean, we could analyze each individual jail, what they have been typing, and do a bit more like data mining on that or research. Especially when there's a lot of students struggling or a single student is struggling like all the time, we could really look at the console log or the history of the shell, what has been typed. Yeah, that's actually a good idea.
But maybe it's a problem with the German data protection law.
That too, yeah. But for me, as the teacher of such a class, I will not, publish this somewhere. But I will definitely, if a student has struggled with this for 2 labs or so, I could do a private talk in my office with them and say, hey, is this difficulty really your thing, or are you not studying enough? And the immediate feedback is what you get from the system, rather than me figuring this out. Oh, the student didn't get a good grade, but I cannot help that student anymore because the class is over.
Any other questions?
One more?
Yeah, maybe another question. Does the students that uses AI ends up with Linuxism?
Probably, yeah. So we analyzed how good the students were with AI or without, and it turned out they didn't make it much better if they couldn't properly prompt the problem. And so understanding of the problem that you're seeing is also important still, rather than just entering, I have a system where the package upgrade didn't work. That would lead them into the wrong path. And the analytical skills is what is also difficult to teach to students, because you typically try to get them to a certain knowledge point, but system administrative knowledge is quite dynamic. You have to figure out, what is the problem? What can I find out, or what kind of systems can I check that are, or the logs maybe, and that's difficult to teach. You have to try this out on your own and learn over time.
And of course, we find out that if students find a solution by yourself, you get much more skill improvement than you find out with AI.
Yeah, and the satisfaction, oh yes, I solved this problem, now I have a bit more learned this. And I can communicate these problems at home, right? It's not just that I solved this particular artificial scenario here.
And I think there was another question.
Okay.
You mentioned that your students have very little Unix knowledge when they arrive at you. Another thing I noticed is that people coming out of education have a lot of knowledge of legacy IP protocols, but not a lot of knowledge of the current protocol, also called IPv6. So my question is, do you plan to add IPv6 support, and do you plan to even add maybe IPv6 scenarios to this?
So for stuff, networking we could definitely do. We could even give them 2 jails to manage to communicate between them. And the system is actually not limited towards a certain protocol, or we say, okay, we deactivate with the IP NAT rules or with the PF rules that are behind that. We only limit them to IPv6 to do IPv6 scenarios. That's certainly possible. If you can do it on a system, then you can also do it in a jail. You just need to create a scenario around it. Do we have some more slides?
No.
Okay. Thought so.
Any other questions? Or?
So who wants to try this out maybe at a next event?
Perfect.
Okay. Yeah, because the results will be different compared to students, because again, students are still learning, and that's fine and good, but you may have solved these scenarios quite quickly, or may have come up with other scenarios that are also interesting for other people to solve, and overall we all learn, because again, like in the class, we would come together after the scenario has been solved, and someone has won the high score prize, but everyone has different approaches, like how do you find the error? How did you solve it? Which tools did you use? And everyone learns from that, rather than, oh, there's one generic solution that solves all of these. That's typically not the case.
And maybe we come around with really hard scenarios for you that you can find out the solution and improve your skills.
Yeah, we have a year to come up with some of those, right?
I think Benedict and I have enough ideas to torture yourself with stuff like that.
Yeah. Okay, up there, all right. Let me not trip over the cable. We can still do this last one.
Yeah, have you this uploaded somewhere where people maybe can contribute additional scenarios? I mean, this would be great to open source it.
Yeah, so the idea is to do that. We're not there yet. We want to do a little bit of code polishing, but basically everything, if you've written a Bastille file before, then you can also provide a scenario and load this into the system. It's flexible like that. But you also need to define the condition to check what is the right solution or when is the scenario solved. And we can then figure out, okay, what's the actual difficulty, because that influences the points that you get for solving it. All right, but yeah, thanks. We'll take this feedback and, well, 3 times the charm, right? We have always updates to do. And actually this lives from the feedback of people, because the more people I talk to about this idea, the more they have ideas of their own. And that's the exciting part of it, because there could always be more developments in this area.
Yes, and we have already implemented feedback from the BSDCon this year.
All right, thank you.
corpses, so we do not have that for the auction later on, but anyway, take over to Henning.
So, welcome to the closing session of this year's family meeting. As usually, I first want to thank our sponsors, but for next time, your company could be the first in this list for just 15,002 euros. So, talk to your bosses. Our platinum sponsor, again, is Modero. Thank you. Our, I think, first time platinum sponsor, is that right? Is OpenSense. Thank you. Gold, Apple. Iron. FreeBSD Foundation. Oh, those are silver, sorry about this. Netflix. E-card. Our bronze sponsors are Genua, the NetBSD Foundation, Prodotto in Rete, and Tarsnap. Our partners are Skyline Networks, Netzkommune, OpenIT, OpenBSD Amsterdam, and the Lightbirds. The Zagreb team that we want to thank a lot. Boan, Carlo, Marco, Professor Dr. Marin Golup, Philip Bühler, Anna Maria Devcic, Gregor and Lobo. Thank you all so much. You did an awesome job.
Thank you. Thank you.
The video team cannot come on stage because, well, they have things to do. Maybe you can at least get up. Thank you. So that's Misha Peters, Albert Den, Florian Viehweger, Angie Michice, Patrick McAvoy, and Charlie Lee. Thank you. Our streaming sponsor, again, and they have been for many, many, many years, is Scale Engine, with special thanks to Andrew and Alan. The program committee, once again led by Peter Hanstein, Philip Bühler, Tom Jones, Misha Peters, Kristen Nielsen, and Benny Siegert. Thank you. The EuroBSDCon Foundation, Paul de Weert, Guido van Rooij, René Ladan, Philip Bühler, Misha Peters, Harold Gotch, Henning Brouwer, Katie McMillan, Jeroen Janssen, and Peter Hanstein. we do have the Paul Schenkewald travel grant. If you know anybody who Schenkewald. I'm so sorry for my poor Dutch. If you know anybody who really should be at the next EuroBSDCon, but he or she cannot afford the trip and the associated costs, please point them to the travel grant. We will cover the travel, the hotel, free admission to the conference, and yeah, at least please advertise. If you require a certificate of participation, please use the link to tickets.eurobsdcon.org that you had in your order confirmation email. Then buy the certificate of participation product, and we will send you a PDF, hopefully somewhat timely. Since that involves, and that's the problem with doing it timely, it involves quite a bit of manual work, so we are asking a €5 token fee. This year, we have 221 family members in here. The largest group, surprise, is the Germans, followed by the US, Switzerland, the Netherlands, Croatia, Norway, the UK, Sweden, Italy, and France. Flags are hard. We have this wonderful family photo. The QR code directs you to our wrap-up page where this is linked to from. I'll give you a little bit of time for the QR code. I still see some phones out there. We do want to hear from you, and we do want you to spread the word what a great conference EuroBSDCon is, so we get even more people to come, maybe even more people to speak. The QR code links to the very same page as the last one, so if you got that, you don't need to scan it again. Graph handover. I have nothing to do with that. Where's the handheld?
I officially give Groff over to you. Thank you. I will make sure Groff makes it to his next required location.
Sato-san, the stage is yours if I get the microphone back.
Oh, thank you. So let me make a small announcement about EuroBSDCon. So I'm an organizer of the EuroBSDCon a long time. So my name is Hiroki Sato. And yeah, next one is already surrounding. So I'm so sorry about if you plan to visit Tokyo last March because EuroBSDCon 2025 need to be canceled for some, it is difficult to explain the bad reasons. But the next one actually organized in Taiwan, Taipei, in March 19th to 22nd, from Friday to Sunday, just like EuroBSDCon. So please consider to submit your work and visit the Taiwan island. And please make sure, so please do not get the wrong idea about between mainland China and Taiwan. It's a totally different. So I am Japanese. The Japanese government did not recognize Taiwan as a country, so I cannot say Taiwan is a country. But Taiwan have a bit difficult and complex political conflict with so Japan and mainland China and Taiwan. But we are friends, and So Taiwan wants more people from Europe and the US, and especially EuroBSDCon in Taiwan will have a lot of young students from the local university who are interested in the system programming. So please come there and make a connection with them. And so this is a distance from Zagreb. And to Tokyo, there are no difference. Probably Taiwan is 100 kilometers or 200 kilometers nearer than the Tokyo. So you have to prepare for the over 11,000 kilometer flight. So it takes 14 hours to 15 hours, unfortunately. But yeah, it will give excellent experience if you visit Taiwan. Okay, so next one, please. So we will open the call for papers in the October, and this is the target date. And the official website is not yet updated. I will update the official website in the next week. And this time, the organization team will work hard to keep up with the schedule because the EuroBSDCon tends to be make a significant delay of the original plan. But at this time, we are working hard. So please consider submit your great work, and it's in any form of attendance is welcome. So we are preparing the live streaming and the recording and good set of communication tools for you. So please do not remember please remember the EuroBSDCon is still running, and so organization team is waiting for you. Thank you.
Another sister conference I just do myself, since I had nobody poking me that they want to do it. So BSDCon 2026 is, surprise, going to be in Ottawa. It's June 17th to 20th, and yeah, well, that's BSDCon. Now we get to our auction. Philip collects the money, I just decided. The first item is a keyboard, IBM M, what were they called, Type M? Model M?
Remake, but it's the really heavy-duty thingy. So like 2 kilograms, you can slap your coworkers with it easily.
They have a very useful connector too. It's yours. It's yours. As soon as you pay Philip. €50. Totally legit. Okay.
100 is more than 50.
Good point. Good point. Anything worth more than 100 Serbian dinar. I have no idea how much that actually is, but.
It's like 10 cents.
Whatever. Serbian dinar. It's yours. Of you who dress a bit classier than I do, a tie. It's been the speaker's gift. Tom, 100?
I was going to start with 20, but yeah.
100. It's black.
No, blue.
It's the other black. Do I hear more than 100? No. Tom, it's yours. just have no idea what this is good for.
Is it you?
I don't know.
A hard lamp or whatever.
I have no idea what this is for.
Cable management.
Come on, €1 at least. 1 euro. 20. And you think you can make use of that opposed to me? Oh, that's what it's for. Anybody willing to pay more than 20 for this? Oh.
He said I collect the money.
The money will go to a local charity, which the locals have to select still. So we have...
It is an animal shelter or something like that, yeah. Taking care of sick animals. No, that's the story.
Now, I have a book about the best firewall in the world, and I'm not biased at all. The Book of Kiev, signed by both the author, Peter, wherever he is right now, and me. What? Come on. Do I hear...
20, but I don't have cash on me this time.
We'll figure that out.
20.
25. Do I hear 30 or more? 30, 35, 40, 40, 50, 50, 50, 60. Do I hear 70? Do I hear 10,000? 15,002. It's yours. Okay, what was that? 60, right? 60? Was it you? Who was it? You, sorry. Okay, do I hear more than 60? It's yours. A travel adapter. Used, we don't know by whom. It converts US and I guess UK to European.
Does it work?
How would I know? I presume it works, we have not tested it. Do I hear €5? 5. Do I hear more? Do I hear 10? It's yours. I have another of those wonderful keyboards. Do I hear 10? 50? 60? 100? It's yours. A wonderful free BSD t-shirt, size L. Do I hear 20? 50? 70? L, large. Okay, it's yours. That was 70, right? Yeah. Untested, and I have no idea what it is. Do I hear 5? I don't even know whether it belongs together, really.
No, it's just for the doing HDMI to VGA or the other way around, or it doesn't work at all. It's 10.
It has a VGA port, it has 2 audio jacks, it takes 5 volts DC, it has HDMI, it comes with, it goes for 10 euros. Do I hear more than 10? 12? 20? 25. Do I hear 30? I take that as a yes, Misha. 50.
I'm not offering 50. I already paid 50 for it.
Okay. It's yours. A speaker's tie in
Red.
Purple, red-ish. 10 euros. 20. 30. You already got one. Anyway, you can buy as many as you want. What was it? 30. 50. More than 50, anyone? 60. Anybody in for 70? 70. Well, I guess it's yours. Blumen 70. Let's see. An open sense cap. Do I hear 10? 15 or 50? 50. More than 50, anyone? It's yours. Run Your Own Mail Server by Michael Lucas. This one comes with a sponsor-exclusive challenge coin. The only way to get it was to sponsor the book as Michael wrote it.
20.
50. Do I hear 60? 70. 80. 100. Who was that? Who was the 100? You. 100. Do I hear 120? Do I hear 140? Well, I guess it goes to Finland. I have a wonderful keyboard. 50. Do I hear 60? Anybody in for 70? Anybody in for 80?
Think of the animals.
80. It's for the animals, right? So, it's yours for 80. A pair of wonderful glasses. 10?
10.
Well, we already had 10. 20?
30.
30. Come on, you can't get cooler than this. And actually, you can be my twin. Where were we, 20?
30.
30. Anybody in for 40? Okay, it's yours.
Deal with it.
You, smiley stickers. We've used some, but there's leftovers. Do I hear 10? 20? Anyone? 10 euros is a good deal because they cost €1. A tie, and I think we can all agree on this is actually blue. Anybody in for 10? Anybody in for 20? 20. 30? 40? 50? 60? How many ties do you need, Tom? Anyway, it's for the animals, right? 70, anyone? 70. 80, anyone? It's yours. You'll get another chance, perhaps. Another set of glasses. Shades, pretty sporty, bit wobbly. 10, 20. It's yours. Now, the hottest item in the auction. This little piece of origami has the name of next year's location. 20, 30, 40, 80, 99. Okay, we'll
didn't, and I'm sick of it. I'm getting it.
So the next step is obviously 111.
112, god damn you!
Go on. How much?
120.
120.
123.
More than 123, anyone? Well, I guess it's yours. Guess what? I have a keyboard. 30. Who said 50? 50? More than 60, anyone? 70? It's yours.
60.
Yeah. There's this wonderful firewall package. The Book of PF, 3rd edition, signed by the author, and, well, so I'm sorry, but my signature is in there too. 20. Do I hear 30? 50. Do I hear 60? 70. The official price is $35. Oh, no. Sorry, I screwed this up. The official price is $46 Canadian. And now I forgot where we were. How much was the last bid? 60? 80. Do I hear 90? 100. Who was that? Yeah. 110. Who's in for 120? Who's in for 150? Well, then it's yours for 120, and this was the last one. 120, I do have a tie. It's red and purple, I guess. 50. Who's in for 60? 60. Who's in for 70? 70. Who's in for 80? Okay, happily, 450? 450? 400? 108? Okay. Tom, 108. Oh, what do I have left here? FreeBSD Mastery Jails, and this is a very special edition. It's the Bail Bond Denied edition. The cover art you would have gotten if Michael had been in jail. Only 5 copies exist, and this is the last one. There won't be another. Okay, we started at 50. Who's in for 60? Who's in for 70? Who's in for 80? 90? 100? It's yours for 90. I have a keyboard. So we have 50. Who's 70. Who's in for 80? This is actually the last one. Who's in for 80? It's yours for 70. I have a shirt from Immunes.net, University of Zagreb, size
50.
Size Henning needs glasses. Size M, 50. Do I hear 60? 60 over there. Who's in for 70? Who's in for 70? It's yours for 60. 70. Who's in for 80? Who's in for 90? Come on, Bit Wars. It's for the animals. Was that 70? Yeah. Okay, it's yours for 70. I have a blue piece of ribbon thing. Who's in for a euro? Who's in for a euro? 5 euros. Who's in for 10? Who's in for 15? Okay, it's yours for 10 euros. Thank you. I have a tie. It's blue. 40. Who's in for 50? 50. Who's in for 60? 60. 60. Who's, well, now you have to pick 70. 70, because there's 2 at 60 now, so you have to fight this out. 70. What do we do with 2 bits for 60? This is the last one. 65, come on. 70. Well, another tie to Tom. The very, 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 very last conference t-shirt, size large. Anybody in for 50? Anybody in for 60? It's yours. Anybody interested?
-5. -5. Do we have any other bids?
Okay, you want it for 5?
No, I'm bidding over you.
8? Well, so thank you all so much. The animals will be very, very happy. That's the end of the conference. Bye-bye.
I have an item here which answers what you all want to know. It costs me 123. Do you have a 130? Oh wait, I give it to you later. And there's some more stuff over there, like some lost luggage. We could either auction it off for those people who have the correct badge with them still. Please come down to the stage later after the very last slide is there, so you can pick it up here and we do not hold it around. You have seen that. What else? Let me check. What?
I think you should leave the trolling to the chief trolling officer.
Oh, it goes by itself.
Well, that's up to you guys. I'm not going to sing.
No, you have to think.
But what you are thinking?
What are you thinking about, exactly? Well, you probably noticed I was trolling a little bit, which must come as a very big surprise to all of you who've been to a EuroBSDCon before. There's this one thing left. Where are we going to be next year? And I'll give you a hint. The country we are going to be in is a beer country. The inventor of the saxophone is from that country. It's the former home of the world's longest tram line, and it has the busiest railway tunnel in the world. The country's independence started with a riot and an opera. Ugh. The city claims it was built on 7 hills. The city name cannot be written. The city name cannot be written in 7-bit ASCII in local language. The city name can be written in 7-bit ASCII in local language. It is very EU. They have the largest Art Deco building in the world. The largest Art Deco building in the world. Some people have more culture than me. That's the flag. Oh, sorry. So, we are going to be in Brussels. One of the official languages in Belgium is German, and in German, Brussels has an umlaut. In the other two official languages, there's no umlauts. So they are 7-bit clean. Christoph, please come up to stage.
So I have a few. The first one is my deep and unending disappointment that Lucas didn't bid on the location, or didn't get it rather, because I owe him some trolling. As we've said, yes, and this is our artwork. I have been dying to share the artwork with you by one of our local artists, and I'm incredibly happy with the artwork. There were two other things I had to tell you. Henning skipped it, but this city also has 5 parliaments, and I'm not going any further until I hear the name of all 5 of them. So let's go. Number 1. EU. Number 2. Be more specific. The Flemish Parliament is also correct. That's number 2. Number 3. That is incorrect. The Walloon Parliament is in Namur. The Federal Parliament is correct, and I've heard the Brussels Parliament, this is also correct. They're not parliaments. I'm missing one. Thank you, that is number 5. We can proceed. Important in Brussels, this is the Free University of Brussels. You should not confuse this with the ULB of Brussels or the Free University of Brussels. If you turn up at a university campus and you recognize it from FOSDEM, you are in the wrong place. I had more notes for you, just one moment. Oh yes. The website will go live soon. Just as soon as Misha pulls the trigger, the website will be live. Oh, there we go, the website is live. There is a link to the attendee hotel. The nice people of the attendee hotel told me that they will set 50 rooms aside for us, but they will only hold them for the next 6 months. Sign up early, sign up often. And then one last thing, to whoever bought this power adapter, I'm afraid to say it's not going to work in Belgium. Our power plugs are subtly different from the German ones. Ours have, I'm desperately trying to avoid the word erection here. We have a metal prong in our for our ground plug, so not all of your adapters will work. Pay attention to this. Other than that, I hope to see you all. Sorry? Yeah, don't do that. Don't stick pliers in power plugs. It's very funny to watch for the rest of us, but it's not great for you. I think I've covered everything. I hope to see you all and your friends and your family there in Brussels next year.
And that's it for real now. Those who stored their luggage with us, please come pick it up. Safe travels home. I really enjoyed this conference. I hope you did too. See you next year. You can turn off the lights now.